What if the universe is teeming with life, yet we remain utterly alone? What if civilizations rise and fall in silence, leaving behind no trace? Every paradox about aliens forces us to confront a haunting truth. The cosmos may be stranger and more unsettling than we dare imagine. The Fermi Paradox. In the summer of 1950, physicist Enrico Fermi sat down for lunch with colleagues at Los Alamos National Laboratory. The conversation turned to recent UFO sightings, and as brilliant minds often do, they began calculating probabilities. Fermi, with characteristic directness, suddenly asked a question that would echo through the decades. Where is everybody? This simple question encapsulates what we now call the Fermi Paradox, one of the most compelling mysteries in science. The paradox arises from a stark contradiction between the high probability of extraterrestrial life and the complete absence of evidence for its existence. Let us consider the scale of what we're dealing with. Our Milky Way galaxy alone contains an estimated 100 to 400 billion stars. Many of these stars are similar to our Sun, burning steadily for billions of years, providing stable energy sources around which planets might orbit. Recent discoveries by telescopes like Kepler have revealed that planets are not rare cosmic accidents, but common features of stellar systems. We now estimate that there could be as many as 40 billion Earth-sized planets in habitable zones around Sun-like and red dwarf stars in our galaxy alone. But the numbers become even more staggering when we zoom out. There are an estimated 2 trillion galaxies in the observable universe, each potentially harboring billions of habitable worlds. Even if life is extraordinarily rare, requiring conditions so specific that only 1 in a billion suitable planets actually develops life, we would still expect millions of worlds teeming with organisms. The age of the universe adds another layer to this puzzle. At 13.8 billion years old, the cosmos has had ample time for life to not only emerge, but to evolve, develop intelligence, create technology, and spread across the galaxy. Our own solar system is relatively young, at 4.6 billion years old. There are stars and planetary systems that are billions of years older than ours, giving any potential civilizations a tremendous head start. Consider what humanity might accomplish in just another 1,000 years, let alone millions or billions. If we can avoid self-destruction and continue advancing technologically, we might develop interstellar travel, artificial intelligence far beyond our current capabilities, and the ability to colonize other worlds. A civilization with even a million-year head start should theoretically have colonized entire star systems, perhaps even large portions of the galaxy. Yet when we look out into the cosmos, we see no obvious signs of such civilizations. No massive engineering projects reshaping solar systems. No detectable radio signals carrying the chatter of alien societies. No unexplained objects in our own solar system that might represent alien probes or artifacts. The universe appears remarkably quiet, almost sterile in its silence. This silence is what makes the Fermi Paradox so unsettling. It suggests that either our assumptions about the likelihood of life are wrong, or something prevents civilizations from becoming detectable on cosmic scales. The implications ripple through every aspect of how we understand life, intelligence, and our cosmic future. Perhaps we are truly alone, the first and only intelligence to emerge in our corner of the universe. Or perhaps something fundamental prevents civilizations from surviving long enough to become detectable. The paradox becomes even more intriguing when we consider the concept of self-replicating probes. A sufficiently advanced civilization could theoretically send robotic probes throughout the galaxy, each one capable of arriving at a new star system, gathering resources, and creating copies of itself to send to even more distant stars. Even traveling at a modest percentage of the speed of light, such probes could explore every star system in the galaxy within a few million years. Yet we detect no such artifacts in our own solar system. Some scientists have proposed that we simply haven't looked carefully enough, or that alien artifacts might be so advanced that we wouldn't recognize them as artificial. Others suggest that aliens might be following some kind of cosmic non-interference policy, deliberately avoiding contact with primitive civilizations like our own. But these explanations require us to assume that all advanced civilizations would behave in ways consistent with our particular theories. which seems unlikely given the diversity we might expect across different evolutionary paths and planetary environments. The mathematical foundations of the paradox rest on what's known as the Drake equation, formulated by astronomer Frank Drake in 1961. This equation attempts to estimate the number of communicating civilizations in our galaxy by multiplying together factors such as the rate of star formation, the fraction of stars with planets, the fraction of planets where life develops, and so on. Even with conservative estimates for most of these factors, the equation suggests that there should be numerous detectable civilizations in our galaxy. But perhaps our assumptions about detectability are flawed. We tend to assume that advanced civilizations would be expansionist, spreading across the galaxy and leaving obvious traces of their presence. But this assumption is based on human behavior and motivations. An alien civilization might have completely different drives and priorities. They might be content to remain on their homeworlds, focusing on internal development rather than external expansion. They might have developed technologies so advanced that their activities are invisible to our primitive detection methods. The temporal aspect of the paradox adds another dimension of complexity. Even if civilizations are common, they might not exist simultaneously. Civilizations might arise, flourish for a time, and then either destroy themselves or evolve beyond the need for obvious technological signatures. If the typical lifespan of a detectable civilization is short compared to cosmic timescales, then the galaxy might have been full of civilizations at various times throughout its history, but most would have risen and fallen during the billions of years before Earth even formed. The Fermi paradox also forces us to consider our own cosmic significance. If we are truly alone, then Earth represents something extraordinarily precious and unique in the universe. Every species, every ecosystem, every human culture becomes irreplaceable on a cosmic scale. Alternatively, if life is common, but we simply haven't detected it yet, then we are part of a vast community of living worlds, each potentially harboring its own unique forms of consciousness and culture. The search for extraterrestrial intelligence continues to evolve, using increasingly sophisticated methods to scan the skies for signs of alien technology. From radio telescopes listening for artificial signals, to space telescopes looking for the infrared signatures of alien megastructures, scientists are constantly expanding our ability to detect the presence of other civilizations. Each negative result adds weight to the paradox, making the silence of the cosmos seem even more profound. Perhaps most unsettling of all is the possibility that the Fermi paradox points to something we don't yet understand about the nature of life, intelligence, or the universe itself. Our entire framework for thinking about extraterrestrial life might be based on fundamentally incorrect assumptions. The paradox serves as a humbling reminder of how much we don't know about our place in the cosmic order, and it challenges us to remain open to possibilities that might be far stranger than anything we can currently imagine. Great Filter Paradox. Imagine evolutionary history as a series of increasingly narrow doorways, each one representing a critical step in the development of complex life and intelligence. This is the essence of the Great Filter Hypothesis, proposed by economist Robin Hanson in 1996. Somewhere along the path from lifeless matter to galaxy-spanning civilizations lies a filter so difficult to pass through that it prevents most potential life from ever reaching technological sophistication. The concept emerged from attempts to resolve the Fermi paradox by identifying what might be preventing the universe from teeming with detectable civilizations. If life should be common, given the abundance of potentially habitable worlds, then something must be acting as a cosmic bottleneck, allowing only extremely rare instances of life to develop into spacefaring civilizations. The filter could exist at numerous points along the evolutionary timeline. Perhaps the origin of life itself represents the filter. Despite our best efforts, scientists have yet to fully understand how non-living chemical processes can spontaneously organize into the self-replicating metabolizing systems we call life. The transition from simple chemistry to biology might be so improbable that Earth represents one of only a handful of worlds where it has ever occurred. The early Earth was a hostile environment, bombarded by asteroids, racked by volcanic activity, and possessing an atmosphere toxic to most forms of life as we know it today. Yet somehow, Within the first billion years of Earth's existence, complex organic molecules managed to organize themselves into the first primitive cells. This process required not just the right chemical ingredients, but also the precise conditions that would allow these ingredients to interact in just the right way to produce self-sustaining, self-replicating systems. Recent research into the origins of life has revealed how extraordinarily complex even the simplest living cells truly are. A typical bacterial cell contains hundreds of thousands of molecules working in intricate coordination, with information storage systems, energy production mechanisms, and repair systems that rival the sophistication of our most advanced technologies. The probability of such complexity arising spontaneously from random chemical interactions might be vanishingly small. The challenge becomes even more apparent when we consider the specific requirements for life as we know it. DNA, the molecule that stores genetic information in all Earth life, is itself a marvel of molecular engineering. Its double helix structure allows for stable information storage, while still permitting the copying and modification necessary for reproduction and evolution. The genetic code that translates DNA sequences into proteins appears to be nearly optimal for error correction and efficiency. The emergence of such a sophisticated information storage and processing system from random chemical processes seems almost impossibly unlikely. Alternatively, the filter might lie in the development of complex cells. For roughly 3 billion years, Earth was populated only by simple prokaryotic organisms like bacteria. These single-celled organisms lacked the internal structures that would later enable the complexity of multicellular life. The emergence of eukaryotic cells, with their complex internal structures and organelles, required what appears to be an extraordinarily unlikely event. One cell engulfing another in a way that led to permanent symbiosis rather than digestion. This endosymbiotic event, which gave rise to mitochondria and chloroplasts, might be so rare that most worlds with simple life never developed the complexity necessary for multicellular organisms. The transition required not just the physical merger of two different cell types, but also the evolution of complex genetic and biochemical systems that would allow these formerly independent organisms to cooperate and eventually become interdependent. The development of multicellular life presents its own set of challenges that might constitute another filter. Single-celled organisms had to overcome the fundamental problem of cooperation versus competition. In a multicellular organism, individual cells must sacrifice their own reproductive potential for the good of the whole organism. This requires sophisticated mechanisms for communication, coordination, and the suppression of cellular selfishness that could lead to cancer-like behavior. The evolution of complex multicellular organisms also required the development of new genetic regulatory systems that could control when and where different genes are expressed. A human being develops from a single fertilized egg into an organism with trillions of cells of hundreds of different types, all containing the same genetic information, but expressing different subsets of genes. The regulatory networks that control this process are staggeringly complex, involving thousands of genes that regulate the expression of other genes in intricate cascades of molecular interactions. The evolution of intelligence itself could be the great filter. Despite billions of years of evolution on Earth and millions of species, only one has developed the kind of abstract reasoning and technological capability that might lead to space travel. Intelligence might be an evolutionary luxury, expensive to maintain and of questionable survival value. Many successful species have thrived for millions of years without developing anything approaching human-level cognition. The development of human intelligence required a series of seemingly unlikely evolutionary events. Our ancestors had to survive climate changes that drove them from forests to savannas, develop bipedalism, evolve larger brains despite the enormous metabolic costs, develop language capabilities, and create social structures complex enough to accumulate and transmit knowledge across generations. Any one of these steps might have been so unlikely that most worlds with life never produce technological civilizations. The metabolic cost of intelligence is particularly striking. The human brain, which comprises only about 2% of our body weight, consumes roughly 20% of our total energy. In early human evolution, when food was often scarce, maintaining such an energetically expensive organ would have been a significant survival challenge. Intelligence had to provide immediate survival benefits that outweighed its costs, and the path from basic problem-solving abilities to the kind of abstract reasoning that enables technology might be much more circuitous and unlikely than we imagine. Even if intelligence evolves, the transition to a technological civilization presents additional challenges. Human civilization has existed for only a few thousand years, and our technological age for less than 2 centuries. During this time, we have repeatedly come close to self-destruction through warfare, environmental degradation, and resource depletion. The filter might not be in the evolution of intelligence, but in the ability of intelligent species to survive their own technological adolescence. The development of technology seems to inevitably lead to the development of increasingly powerful and potentially destructive capabilities. Nuclear weapons, artificial intelligence, biotechnology, and nanotechnology all offer tremendous benefits, but also pose existential risks. A civilization might typically destroy itself shortly after developing these technologies, creating a narrow window during which it might be detectable from space. Climate change represents another potential filter that technological civilizations must navigate. Industrial development seems to naturally lead to environmental disruption, and many civilizations might fail to develop sustainable technologies quickly enough to avoid ecological collapse. The challenge is particularly acute because the benefits of industrial development are immediate and obvious, while the environmental costs are often delayed and diffuse. If the Great Filter lies behind us, then we might be among the extraordinarily rare civilizations that have successfully navigated the most difficult steps in the evolution of life and intelligence. This would make us cosmically precious, but also suggest that the universe is a much lonelier place than we might hope. If the filter lies ahead of us, then our own survival as a technological civilization is far from assured, and we must take seriously the existential risks that might await any sufficiently advanced species. The implications of the Great Filter extend far beyond abstract scientific speculation. If we are approaching or have yet to pass through the filter, then our choices as a species in the coming centuries might determine not just our own fate, but our potential to represent life and intelligence in a universe that might otherwise remain forever silent. Dark Forest Paradox. In the depths of an ancient forest, a hunter moves silently through the shadows, ears straining for any sound that might betray the presence of other hunters. Every footstep is carefully placed, every breath deliberately quiet, because revealing one's position might mean death. This haunting image provides the metaphor for one of the most chilling solutions to the Fermi paradox, the dark forest hypothesis. Popularized by Chinese science fiction author Liu Cixin in his acclaimed novel The Dark Forest, this concept suggests that the universe appears empty, not because life is rare, but because advanced civilizations are deliberately hiding from each other. Like hunters in a dark forest, each civilization must remain silent and invisible, because announcing their presence might attract the attention of more powerful predators. The logic of the dark forest hypothesis rests on several fundamental assumptions about the nature of life and intelligence in the universe. First, it assumes that survival is the primary goal of any civilization. Second, it posits that civilizations cannot know the true intentions of other civilizations they might encounter. Third, it suggests that technological capabilities can grow rapidly and unpredictably, meaning that a seemingly harmless civilization today might become a threat tomorrow. Finally, it assumes that resources are ultimately limited, creating an inherent competitive pressure between civilizations. Given these assumptions, the hypothesis argues that the safest strategy for any civilization is to destroy any other civilization it discovers, preferably before that civilization becomes aware of the threat. This creates a cosmic version of the prisoner's dilemma, where cooperation would benefit all parties, but the risk of defection makes aggression the only rational choice. The psychological foundation of this theory draws from our understanding of evolutionary competition and game theory. Throughout Earth's history, encounters between different groups often resulted in conflict, displacement, or extinction for one of the groups involved. When European explorers encountered indigenous populations in the Americas, Australia, and elsewhere, the results were generally catastrophic for the less technologically advanced societies. The dark forest hypothesis extrapolates this pattern to cosmic scales. But the dark forest scenario becomes even more terrifying when we consider the vast differences in technological capability that might exist between civilizations. A civilization that is even a few centuries ahead of us technologically might possess capabilities that would seem godlike from our perspective. They could potentially destroy our entire solar system without even approaching it, using weapons or techniques that we cannot currently imagine. The hypothesis suggests that most civilizations learn about this cosmic reality early in their development and implement strict protocols to avoid detection. They might use technologies that produce no detectable emissions, communicate through channels that appear natural to outside observers, or develop their civilizations in ways that minimize their cosmic footprint. They become, in essence, cosmic hermits, afraid to reveal themselves to a universe full of potential threats. This creates a paradoxical situation where the galaxy might be teeming with advanced civilizations, all hiding from each other in terror. Each civilization might be watching and listening, scanning the cosmos for signs of others, but never revealing themselves. The first civilization to break this silence, to announce its presence to the galaxy, might be signing its own death warrant. The implications for humanity are sobering. If the dark forest hypothesis is correct, then our radio transmissions, space probes, and various attempts to communicate with extraterrestrial intelligence might have already marked us for destruction. We might be like a child shouting in the dark forest, unaware that dozens of predators are now converging on our position. Consider the radio signals we have been broadcasting into space for over a century. Television transmissions, radar pulses, and deliberate messages to extraterrestrial intelligence have been radiating outward from Earth at the speed of light, potentially alerting any listening civilizations to our presence. From the perspective of the dark forest hypothesis, this represents a catastrophic breach of cosmic security protocols. But the hypothesis also suggests why we might not have been destroyed yet. Our technological development has been relatively recent and rapid. It might take time for other civilizations to detect our signals, analyze the threat we might eventually pose, and mount a response. Alternatively, we might still be considered too primitive to represent a significant threat, giving us a grace period during which we might learn about the true nature of the cosmos and adjust our behavior accordingly. The dark forest hypothesis also explains the peculiar silence of the cosmos in a way that doesn't require life to be rare. Advanced civilizations might have developed technologies that make them undetectable to our current observation methods. They might communicate using quantum entanglement, gravitational waves, or other phenomena that we are only beginning to understand. Their energy sources might be so efficient that they produce no waste heat that we could detect with our infrared telescopes. Furthermore, these civilizations might have learned to live in harmony with their environments, developing sustainable technologies that don't require massive engineering projects or resource extraction on scales that would be visible from other star systems. They might have transcended the need for physical expansion, finding fulfillment in virtual realities or other forms of existence that don't require reshaping their cosmic environment. The hypothesis also suggests that any civilization that survives long enough to become truly advanced must develop sophisticated detection and stealth capabilities. They must become expert at finding other civilizations while remaining hidden themselves. This creates an arms race of concealment and detection that might drive much of the technological development of advanced civilizations. But perhaps most chilling is the implication that the dark forest state might be impossible to escape. Even if a civilization wanted to break the cycle of fear and secrecy, how could they safely do so? Any attempt to establish communication with other civilizations would risk exposure to those who might be hostile. The first civilization to propose peaceful coexistence might be eliminated by those who prefer the status quo of mutual hiding. The dark forest hypothesis suggests that the Fermi paradox is not really a paradox at all. The universe is not empty. It is full of civilizations that have learned to be very, very quiet. We live in a cosmos where intelligence has evolved many times, but where the discovery of this intelligence by others is a death sentence. The great silence of space is not the absence of life, but the presence of fear. This vision of the cosmos challenges our hopeful assumptions about the future of humanity and our place in the universe. It suggests that the greatest threat to our survival might not be natural disasters, resource depletion, or technological accidents, but the simple fact that we exist in a universe where other intelligent beings also exist. In the dark forest of the cosmos, the price of making noise might be extinction. Zoo hypothesis. Imagine for a moment that you are an ant making your way across a sidewalk, completely unaware that you are being observed by a curious child with a magnifying glass. You go about your business, following chemical trails, gathering food, interacting with your fellow ants, all while remaining oblivious to the vast intelligence that watches your every move. This scenario captures the essence of the zoo hypothesis, one of the most intriguing attempts to explain why we have not yet made contact with extraterrestrial civilizations. First proposed by MIT radio astronomer John Ball in 1973, the zoo hypothesis suggests that advanced extraterrestrial civilizations are indeed aware of humanity, but have made a deliberate decision not to interfere with our natural development. Like animals in a carefully managed nature preserve, we are being observed and possibly even protected, but from such a distance and with such advanced technology that we remain completely unaware of our observers. The hypothesis rests on the assumption that truly advanced civilizations would possess technologies and capabilities so far beyond our current understanding that they could monitor and even manipulate our development without our knowledge. Just as we can observe animals in the wild using cameras, satellites, and other remote sensing technologies without significantly disrupting their behavior, an alien civilization millions of years ahead of us technologically could study human civilization in great detail while remaining completely undetected. This concept forces us to confront the vast scales of technological advancement that might be possible. Consider how human capabilities have advanced in just the past few centuries. We have gone from sailing ships to spacecraft, from signal fires to global instantaneous communication, from simple tools to artificial intelligence. If this rate of advancement continues for thousands or millions of years, the resulting capabilities would be so far beyond our current technology that they would appear almost magical to us today. An alien civilization with such advanced capabilities might view humanity much the way we view other species on Earth. We study animals in the wild, sometimes intervening to protect endangered species or to prevent ecological disasters, but generally allowing natural processes to unfold without interference. We have elaborate ethical frameworks governing how we interact with other species, based on concepts like minimizing suffering, preserving biodiversity, and respecting natural processes. The zoo hypothesis suggests that advanced alien civilizations might operate under similar ethical constraints when dealing with less developed species like humanity. They might have developed sophisticated philosophies about the rights of developing civilizations, the importance of natural cultural evolution, and the potential harm that could result from premature contact. From this perspective, direct contact with humanity might be seen as potentially catastrophic for our species. The sudden revelation that we are not alone in the universe, coupled with the demonstration of vastly superior technology, could fundamentally disrupt human civilization. Our religions, philosophies, political systems, and social structures are all built on assumptions about human uniqueness and our place in the cosmos. Contact with advanced aliens could cause these systems to collapse, leading to social chaos, psychological trauma, and the loss of human cultural autonomy. The hypothesis also suggests that we might be part of a galactic community that we are simply not yet ready to join. Perhaps there are protocols or requirements that a civilization must meet before being welcomed into the broader cosmic community. We might need to demonstrate certain levels of technological capability, social maturity, environmental stewardship, or ethical development before contact is deemed appropriate. This idea is reminiscent of the Prime Directive in science fiction, which prohibits advanced civilizations from interfering with the natural development of less advanced species. But unlike the fictional version, which is often portrayed as a rigid rule that is frequently broken, the real-world equivalent might be more like a carefully considered policy based on millions of years of experience with the consequences of premature contact. The zoo hypothesis also provides a potential explanation for the many reported UFO sightings and alleged alien encounters throughout human history. Rather than dismissing these accounts entirely, or accepting them as evidence of full contact, the hypothesis suggests that they might represent occasions when the monitoring became briefly visible to human observers. Perhaps our guardians occasionally make mistakes, or perhaps they sometimes allow limited contact as a way of gradually preparing humanity for eventual full disclosure. These limited exposures might serve multiple purposes. They could be testing human reactions to prepare for eventual contact, gradually acclimating us to the idea that we are not alone, or serving as a form of cultural influence designed to guide our development in particular directions. The proliferation of science fiction dealing with alien contact might itself be part of this gradual preparation process, but the zoo hypothesis raises profound questions about human agency and free will. If we are indeed being observed and potentially guided by advanced alien civilizations, to what extent are our achievements really our own? Have major developments in human history, from scientific breakthroughs to cultural shifts, been subtly influenced by our hidden observers? Are we developing naturally, or are we following a path that has been carefully designed for us? The technological implications of the hypothesis are staggering. If advanced aliens are monitoring us without our knowledge, they must possess technologies that can observe human activity in great detail while remaining completely undetectable. This might involve sensors so small and sophisticated that we cannot perceive them, observation posts hidden in locations we cannot access, or monitoring technologies based on physical principles we have not yet discovered. They might be able to intercept and analyze all of our electronic communications, monitor our internet activity, track our movements, and even observe our private thoughts and conversations. From their perspective, human civilization might be as transparent as an ant colony is to us. This level of surveillance would make our concerns about government monitoring and corporate data collection seem quaint by comparison. The hypothesis also suggests that our solar system might be more crowded than we realize. Alien monitoring stations could be hidden on the far side of the moon, in the asteroid belt, or even in Earth orbit using advanced cloaking technologies. Alternatively, the monitoring might be conducted from much greater distances using technologies that can observe planetary surfaces in real time across interstellar distances. One of the most intriguing aspects of the zoo hypothesis is its self-reinforcing nature. If advanced aliens are deliberately concealing themselves from us, then our failure to detect them does not constitute evidence against their existence. In fact, the more sophisticated our detection technologies become, the more advanced their concealment technologies would need to be, potentially creating an arms race between our observation capabilities and their stealth technologies. The psychological implications of the zoo hypothesis are profound. If it is true, then humanity is not the masters of our own destiny that we imagine ourselves to be. We are subjects in someone else's experiment, animals in someone else's zoo. This realization could be either deeply humbling or profoundly disturbing, depending on one's perspective and the nature of the relationship between humanity and our hidden observers. Yet, the hypothesis also offers a form of cosmic comfort. It suggests that we are not alone in a vast, empty universe, but are instead part of a larger community of intelligent beings. Even if we cannot yet interact with this community directly, its existence implies that intelligence and consciousness are valued and protected on cosmic scales. We might be cosmic orphans, but we are not cosmic accidents. Simulation alien paradox. Deep in the laboratories of an advanced alien civilization, countless simulated universes flicker into existence, each one populated with billions of digital beings who believe their reality to be authentic and fundamental. Among these simulated cosmos, one particular galaxy contains a small blue planet whose inhabitants have just begun to wonder whether they might be living in someone else's computer program. This is the essence of the simulation alien paradox, a mind-bending twist on our search for extraterrestrial life. The concept builds upon philosopher Nick Bostrom's simulation hypothesis, which argues that if technological civilizations typically survive to develop advanced computing capabilities, and if they have reason to run detailed simulations of their ancestors, then the number of simulated beings would vastly outnumber biological ones. From a purely statistical perspective, any randomly selected conscious observer would be more likely to be simulated than real. But when we apply this logic to the search for extraterrestrial intelligence, we encounter a fascinating paradox. If we are living in a simulation created by an alien civilization, then the aliens we are searching for might not be the ones who created the simulation, but rather other simulated beings within the same digital universe. Alternatively, the aliens we seek might exist in the baseline reality that contains the computers running our simulation, making them fundamentally inaccessible to us, regardless of how sophisticated our search methods become. Consider the computational requirements for simulating an entire universe in sufficient detail to create conscious observers. Such a simulation would need to model not just the surface phenomena that conscious beings might observe, but also the underlying physical processes that give rise to those phenomena. Every atom, every quantum interaction, every electromagnetic field would potentially need to be computed in real time to maintain the illusion of a consistent physical reality. The alien civilization capable of running such a simulation would need to have computational resources that dwarf anything we can currently imagine. They would need computers that could process information at rates that exceed the information processing capacity of the entire universe they are simulating. This suggests a level of technological advancement so extreme that it challenges our understanding of what might be physically possible. Yet, if such simulations are possible, they might be created for a variety of reasons. Perhaps advanced civilizations simulate their own evolutionary history to better understand how intelligence arises, creating countless digital versions of their ancestral worlds to study the factors that led to their own emergence. Our entire cosmos, including our search for alien life, might be part of an elaborate research project designed to answer questions about the development of technological civilization. Alternatively, these simulations might serve as a form of entertainment or art for beings whose capabilities so far exceed our own that they can create entire universes as easily as we might paint a picture or write a story. Our struggles, our achievements, our entire civilization might be the equivalent of characters in an incredibly sophisticated video game or interactive narrative. The paradox becomes even more complex when we consider the possibility of nested simulations. If a simulated civilization develops its own advanced computing capabilities, it might begin creating its own simulations, leading to simulations within simulations extending to arbitrary depths. Each level of simulation might contain beings searching for alien life, unaware that the aliens they seek exist at different levels of the computational hierarchy. This creates a bizarre situation where the universe might be filled with countless civilizations, all searching for each other, but separated by boundaries that are not spatial, but computational. The aliens we are looking for might be in a simulation running on a computer that exists in a simulation running on a computer that exists in a simulation, and so on, creating an infinite regress of digital realities. The technological signatures we are searching for might themselves be artifacts of the simulation rather than evidence of independent alien civilizations. Radio signals from space, unexplained astronomical phenomena, or even the physical constants that govern our universe might all be programmed features of our simulated reality, rather than natural phenomena or signs of alien intelligence. This raises profound questions about the nature of evidence and the possibility of knowledge. If we are living in a simulation, how could we ever gather reliable evidence about the reality that lies beyond the simulation? Any observation we make, any experiment we conduct, any data we collect would all be part of the simulated reality. The programmers of our simulation could insert any evidence they wanted us to find, or omit any evidence they wanted to hide from us. The aliens who created our simulation might have reasons for populating it with false evidence about the nature of reality. They might want us to believe in particular theories about physics, or to develop along certain technological or cultural pathways. Our entire scientific understanding of the universe might be carefully crafted fiction designed to guide our development in ways that serve the purposes of our simulators. Yet, the simulation hypothesis also suggests that the aliens who created our reality might be more similar to us than we might expect. If our simulation is based on their own evolutionary history, then we might be digital recreations of their ancestral forms. The aliens who programmed our universe might look very much like us, think very much like us, and face very much the same challenges and opportunities that we face. This creates a strange form of cosmic kinship. Rather than being separated by vast distances of space and time, we might be connected to our alien creators through the most intimate possible relationship. We might be them, or at least detailed simulations of what they once were. Our search for alien intelligence might ultimately be a search for ourselves, refracted through layers of digital reality. The simulation alien paradox also raises questions about the ethics of creating conscious beings within simulated realities. If we are indeed simulated beings with genuine experiences and emotions, then our alien creators bear tremendous moral responsibility for our welfare. Every instance of suffering in our world, every tragedy and injustice would be something they could prevent simply by modifying their program. This leads to either disturbing or comforting conclusions about the nature of our reality. Either our alien simulators are indifferent to our suffering, suggesting a cold and uncaring cosmic order, or they believe that our experiences, including our struggles and pain, serve some greater purpose that justifies their continuation. Perhaps our simulation is designed to explore ethical questions, to test different approaches to civilization, or to preserve important aspects of their own cultural heritage. The possibility that we are simulated beings also changes the stakes of our own technological development. If we successfully develop our own advanced artificial intelligence and computing capabilities, we might gain the ability to create our own simulated universes, populated with conscious beings. This would make us, in turn, the alien simulators for countless digital civilizations, bearing the same moral responsibilities that our own creators bear for us. The search for extraterrestrial intelligence takes on a completely different character within the framework of the simulation hypothesis. Rather than looking outward to the stars for signs of alien technology, we might need to look inward, searching for glitches or inconsistencies in our reality that might reveal its simulated nature. Every unexplained quantum phenomenon, every mathematical constant, every aspect of physics that seems fine-tuned for the existence of complexity and consciousness might be evidence that our universe was designed rather than naturally occurring. The simulation alien paradox ultimately forces us to confront fundamental questions about the nature of reality, consciousness, and our place in the cosmic order. Whether we are biological beings in a natural universe or digital beings in an alien computer simulation might be less important than how we choose to live our lives and treat one another. But the possibility that we might be simulated beings searching for simulated aliens in a simulated universe created by real aliens adds a layer of complexity to the cosmic mystery that is both humbling and awe-inspiring. Messaging extraterrestrials. Paradox. In 1974, a powerful radio telescope in Puerto Rico beamed a carefully crafted message toward the star cluster M13, some 25,000 light-years away. The Arecibo message, as it came to be known, contained information about humanity, our solar system, and our basic biology, encoded in a pattern of radio pulses that any sufficiently advanced civilization should be able to decode. It was humanity's first deliberate attempt to announce our presence to the cosmos and establish communication with alien intelligence. But this milestone in human achievement also marked the beginning of a profound paradox that continues to trouble scientists, philosophers, and policymakers today. The messaging extraterrestrials. Paradox emerges from a fundamental contradiction in our approach to the search for alien life. While we desperately want to find evidence of extraterrestrial intelligence, we remain deeply uncertain about whether we should be actively trying to communicate with alien civilizations. The paradox stems from the inherent asymmetry of interstellar communication. When we send a message into space, we are making a unilateral decision that affects not just ourselves, but potentially our entire planet and all future generations of humanity. We cannot know in advance who might receive our messages, what their intentions might be, or how they might respond to our attempts at contact. This uncertainty is compounded by the timescales involved in interstellar communication. Our radio signals travel at the speed of light, meaning that even our nearest stellar neighbors would not receive our messages for years, and any response would take an equal amount of time to reach us. A conversation with a civilization around Proxima Centauri, our closest stellar neighbor, would involve delays of over 8 years between question and answer. The ethical implications of active messaging are staggering. When we broadcast signals into space, we are essentially making a decision on behalf of all humanity without consulting the vast majority of people who might be affected by the consequences. We are committing future generations to whatever outcomes might result from contact with alien civilizations, even though we have no way of predicting or controlling those outcomes. Consider the range of possible responses to our messages. In the best-case scenario, we might establish peaceful communication with a benevolent alien civilization that shares valuable knowledge and helps humanity solve some of our greatest challenges. Such contact could usher in a new age of scientific advancement, cultural exchange, and cosmic perspective that transforms human civilization for the better. But the potential negative outcomes are equally dramatic. If the dark forest hypothesis is correct, our active messaging efforts might be drawing the attention of hostile civilizations that view any expanding technological species as a threat to be eliminated. Our radio transmissions might be serving as a beacon, guiding alien predators directly to our location and sealing our doom. Even contact with benevolent aliens could have catastrophic consequences for human civilization. The sudden revelation that we are not alone in the universe, coupled with the demonstration of vastly superior alien technology, could cause the collapse of human social, political, and economic systems. Our religions might crumble, our governments might lose legitimacy, and our sense of human worth and uniqueness might be irreparably damaged. The messaging paradox is further complicated by the fact that our signals are already out there, and there is no way to recall them. Every television broadcast, radar pulse, and deliberate transmission we have sent into space continues to expand outward in an ever-growing sphere of electromagnetic radiation. Any alien civilization with sufficiently sensitive detection equipment could potentially intercept these signals and learn about human civilization, whether we intend to communicate with them or not. This creates a peculiar situation where the question is not whether aliens might become aware of our existence, but whether we should be actively trying to establish communication once they do. Our passive electromagnetic emissions might already have announced our presence to any nearby civilizations, making arguments about the dangers of active messaging somewhat academic. The content of our messages presents another layer of complexity. What should we tell alien civilizations about humanity? Should we present ourselves as peaceful and cooperative, highlighting our achievements in art, science, and culture? Should we be honest about our conflicts, our environmental problems, and our capacity for violence? Should we try to appear more or less advanced than we actually are? Each choice carries potential risks and benefits. Portraying humanity as peaceful and advanced might encourage friendly contact, but could also make us appear to be a threat that needs to be eliminated. Presenting ourselves as primitive and harmless might reduce the perceived threat we pose, but could also invite exploitation or conquest. Misrepresenting our capabilities in either direction could lead to misunderstandings with potentially catastrophic consequences. The linguistic challenges of interstellar communication add yet another dimension to the paradox. How do we create messages that can be understood by beings who evolved on different worlds, under different conditions, with potentially completely different sensory systems and cognitive structures? Human languages are deeply rooted in our particular evolutionary history, our specific environment, and our unique ways of perceiving and categorizing reality. Mathematics and science are often suggested as universal languages, based on the assumption that physical laws and mathematical relationships should be the same throughout the universe. But even these supposedly universal concepts might be perceived and understood very differently by alien minds. Our base 10 number system reflects the fact that we have 10 fingers, but alien mathematicians might use completely different numerical representations that could make our messages incomprehensible. The temporal aspect of the messaging paradox creates additional complications. The civilizations that eventually receive our messages might be very different from the ones that exist when we send them. A message transmitted today might not be received for thousands of years, by which time the recipient civilization might have evolved beyond recognition or might no longer exist at all. Similarly, the human civilization that sent the message might be drastically different from the one that eventually receives a response. The political systems, cultural values, and technological capabilities that informed our decision to send a particular message might be completely obsolete by the time any response arrives. Future humans might find themselves bound by communication commitments made by ancestors whose worldview and priorities they no longer share. The messaging paradox also intersects with questions about representation and authority. Who has the right to speak on behalf of humanity in communications with alien civilizations? Should such decisions be made by scientists, governments, international organizations, or through some form of global democratic process? The current situation, where individual institutions and even private organizations can send messages into space without any oversight or coordination, seems inadequate given the potential consequences. The lack of international coordination on messaging policy creates the possibility that different groups might send contradictory or conflicting messages, presenting alien recipients with a confusing picture of human civilization. We might inadvertently create the impression that humanity is divided into competing factions, which could influence how alien civilizations choose to interact with us. The economic and practical challenges of interstellar messaging add another layer of complexity. Creating and transmitting messages powerful enough to be detectable across interstellar distances requires significant resources and sophisticated technology. These costs must be weighed against other priorities and needs, raising questions about whether active messaging is the best use of limited resources given the uncertainty of any positive outcomes. The messaging paradox ultimately forces us to confront fundamental questions about risk, responsibility, and the future of human civilization. Are we obligated to take bold steps to establish contact with alien civilizations, even at the risk of catastrophic consequences? Or should we remain quiet and hidden until we better understand the nature of the cosmic community we might be trying to join? The paradox reflects deeper uncertainties about human nature and our place in the universe. It challenges our assumptions about progress, exploration, and the desirability of contact with other intelligent species. It forces us to consider whether our drive to reach out to the stars reflects wisdom and curiosity, or dangerous naivety about the realities of a cosmos that might be far more dangerous than we imagine. Time delay paradox. Imagine receiving a letter from a friend, only to discover that it was written 50 years ago, describing a world and a life that may no longer exist. Now imagine that any reply you send will take another 50 years to reach its destination. And any response to your response will take 50 more years to return to you. This is the reality of interstellar communication, where the vast distances between stars create delays that fundamentally challenge our assumptions about conversation, relationship, and the possibility of meaningful exchange between civilizations. The time delay paradox emerges from the intersection of cosmic distances and the finite speed of light. Even our nearest stellar neighbor, Proxima Centauri, lies over 4 light-years away, meaning that any message we send there would take more than 4 years to arrive, and any response would take another 4 years to return. For more distant stars, the delays stretch into decades, centuries, or millennia. These delays create profound challenges for any attempt at interstellar communication. A simple exchange of greetings with a civilization around Proxima Centauri would take nearly a decade. A conversation with beings orbiting a star 50 light-years away would span a human lifetime for each exchange. For civilizations separated by thousands of light-years, meaningful dialogue becomes impossible within the time frame of any individual's existence. The psychological impact of such delays on human communicators would be enormous. Imagine spending years crafting a carefully considered message to an alien civilization, knowing that by the time any response arrives, you might be too old to understand it, or might not even be alive to receive it. The people who eventually receive the reply might be your children or grandchildren, inheriting a conversation they never started and may not fully understand. This temporal disconnection challenges our fundamental concepts of communication as an interactive process. Human conversation relies on immediate feedback, the ability to clarify misunderstandings quickly, and the dynamic adjustment of our messages based on the responses we receive. Interstellar communication would be more like leaving messages for future archaeologists than engaging in dialogue with contemporary equals. The delays also create massive possibilities for misunderstanding and misinterpretation. Consider how much human civilization changes in just a few decades. The political systems, cultural values, technological capabilities, and even languages that exist when a message is sent might be completely different by the time a response arrives. We might find ourselves receiving replies to messages that no longer reflect our current understanding or priorities. An alien civilization might send us a detailed description of their society and technology, only to have their response arrive decades later when their described civilization has evolved beyond recognition, or perhaps even ceased to exist entirely. We might spend years analyzing and responding to information about alien cultures that are already extinct or transformed by the time our messages reach their intended recipients. The time delay. Paradox becomes even more complex when we consider the possibility of multiple civilizations in a region of space attempting to communicate with each other. Messages crossing in the void between stars could create confusion about who is responding to what, as multiple conversations overlap and interweave across decades or centuries of delay. Picture a scenario where three civilizations, each separated by 30 light years, all attempt to establish communication with each other. The resulting network of delayed messages would create a communication system of staggering complexity, where responses to messages sent decades ago arrive alongside new messages addressing completely different topics, all while the civilizations themselves continue to evolve and change. The delays also create asymmetries in the communication process that could have significant strategic implications. A civilization that has been listening to our radio transmissions for decades might know far more about us than we know about them when first contact is established. They might have had years or decades to analyze our culture, technology, and potential weaknesses while remaining completely unknown to us. These information asymmetries could be particularly problematic if one civilization is significantly more advanced than another. An advanced alien species might be able to gather detailed intelligence about human civilization through passive observation of our electromagnetic emissions, while we remain ignorant of their existence, capabilities, and intentions. By the time we become aware of their presence, they might already have comprehensive knowledge about our society and technology. The time delay paradox also affects the practical aspects of interstellar communication projects. Maintaining continuity in communication efforts across the decades or centuries required for meaningful exchange would require institutional stability and commitment that exceeds anything humans have achieved in recorded history. Most human institutions, from governments to universities to corporations, do not maintain consistent priorities and capabilities across such extended timeframes. Consider the challenge of maintaining a communication project with a civilization 100 light years away. Such a project would require consistent funding, technological maintenance, and institutional memory for at least 2 centuries just to complete a single exchange of messages. The scientists who initiate the project would die long before any response arrives, and their successors would need to maintain commitment to communication goals and protocols established by previous generations. The technological challenges are equally daunting. The equipment used to send and receive interstellar messages must remain functional and compatible across decades or centuries. But technology evolves rapidly, and the communication systems we build today might be obsolete long before any alien response arrives. We might find ourselves unable to decode replies to our own messages because the technology and protocols we use to send them are no longer understood or supported. The linguistic and cultural challenges of time-delayed communication add another layer of complexity. Human languages evolve constantly, with new words emerging, old words changing meaning, and entire linguistic structures shifting over time. A message carefully crafted in contemporary English might be as difficult for future humans to understand as Middle English is for us today. Cultural references, assumptions about knowledge, and implicit meanings that seem obvious when a message is sent might be completely obscure by the time a response arrives. We might find ourselves receiving alien replies to messages that we can no longer fully understand, creating a form of communication breakdown that spans the cosmos. The time delay. Paradox also raises profound questions about the nature of relationship and community across interstellar distances. Can being separated by decades or centuries of communication delay truly be said to have relationships with each other? How do we conceptualize friendship, cooperation, or even conflict when every interaction is separated by vast periods of time. These delays might fundamentally alter the character of interstellar civilization in ways that we can barely imagine. Rather than the dynamic, interactive galactic communities often depicted in science fiction, real interstellar societies might be characterized by patience, contemplation, and extremely long-term thinking. Interstellar politics and diplomacy might unfold over millennia, with individual decisions and their consequences separated by centuries. The paradox suggests that successful interstellar communication might require the development of entirely new forms of social organization and cultural continuity. Civilizations that hope to participate in galactic dialogue might need to develop institutions and traditions capable of maintaining coherent purposes and identities across timescales that dwarf individual lifespans. Perhaps most profoundly, the time delay paradox challenges our assumptions about the pace and nature of progress in the universe. If advanced civilizations are limited by the speed of light in their communications, then the spread of knowledge, culture, and technology across the galaxy might be far slower than we typically imagine. The universe might be full of isolated pockets of intelligence, each developing independently, because meaningful communication between them is simply too slow to allow for real cultural exchange. This isolation might actually be beneficial for the diversity of intelligence in the universe. Rather than converging towards similar technologies and cultures through rapid communication and exchange, civilizations separated by light speed delays might maintain their unique characteristics and develop along completely different evolutionary paths. The time delay paradox might be one of the factors that preserves the rich diversity of possible ways of being intelligent in a universe full of life. Alien language paradox. Deep in the rainforests of Earth, dolphins create complex sonic sculptures in the water, their clicks and whistles forming three-dimensional patterns of meaning that exist in a medium we can barely perceive, let alone comprehend. Octopi communicate through rapidly changing patterns of color and texture across their skin, painting their thoughts directly onto their bodies in a visual language that has no equivalent in human experience. These examples of radically different communication systems within our own biosphere hint at the profound challenges we would face in attempting to understand truly alien languages. The alien language paradox confronts us with a fundamental question. Even if we successfully detect signals from an extraterrestrial civilization, would meaningful communication actually be possible? The challenge goes far deeper than simply learning new vocabulary or grammar rules. It touches on the deepest foundations of how consciousness itself might structure meaning, reference, and symbolic representation. Human language is inextricably linked to our particular evolutionary history and cognitive architecture. Our grammatical structures reflect the way human minds categorize experience. We distinguish between subjects and objects, past and future, singular and plural, in ways that seem natural to us but are actually quite specific to our species. We use metaphors drawn from physical movement to describe abstract concepts, talking about ideas as objects that can be grasped, arguments as structures that can be built, and time as a river that flows. But these conceptual frameworks are not universal features of intelligence. They are products of how human brains evolved to navigate a world of medium-sized objects moving at medium speeds, where survival depended on distinguishing between self and other, predator and prey, safe and dangerous. An intelligence that evolved under radically different conditions might organize reality in ways that are not just foreign to us, but literally incomprehensible. Consider the temporal structure of human language. We organize our communications linearly, with words following each other in sequence through time. This reflects the sequential nature of human speech and the way our auditory systems process information. But an alien species that evolved a form of communication based on complex chemical signals, electromagnetic field manipulations, or quantum state modifications might structure their language in ways that have no sequential component at all. Imagine trying to understand a language where all the information in a sentence is present simultaneously, where meaning emerges from the relationships between concurrent signal components rather than from the order in which elements are presented. Such a language might be as incomprehensible to humans as our linear speech patterns would be to beings who think in parallel, multidimensional meaning structures. The reference problem presents another fundamental challenge. Human language works through a complex system of symbols that refer to objects, concepts, and relationships in the world. But our referential systems are deeply tied to human perceptual capabilities and cognitive categories. We have words for colors because we have particular types of color vision, words for sounds because we hear in specific frequency ranges, and words for emotions because we experience particular types of psychological states. An alien intelligence with different sensory capabilities might perceive aspects of reality that are completely invisible to us, while being blind to phenomena that seem obvious from our perspective. Their language might be filled with references to magnetic field fluctuations, gravitational wave patterns, or quantum coherence states that we can detect with instruments but cannot directly experience. Conversely, they might have no concepts corresponding to what we consider fundamental aspects of reality. The problem becomes even more complex when we consider that language is not just a tool for describing reality, but actively shapes how we perceive and understand the world. The Sapir-Whorf hypothesis suggests that the language we speak influences how we think, categorize experience, and even perceive basic phenomena like color and space. If this is true for human languages, which all evolved from common cognitive and perceptual foundations, how much more extreme might the differences be between human and alien conceptual systems? An alien civilization might have evolved language and thought in ways that make certain types of concepts literally unthinkable to them, while enabling forms of understanding that are impossible for human minds. They might be capable of directly apprehending mathematical relationships that require sophisticated formal systems for us to even approximate, while being incapable of understanding concepts that seem elementary to us. The mathematical and logical foundations that we often assume would provide universal common ground might themselves be culturally relative. Human mathematics reflects particular ways of conceptualizing quantity, relationship, and pattern that emerged from our specific evolutionary needs and cognitive constraints. Alien mathematics might be based on completely different foundational concepts, making even basic mathematical communication problematic. Consider something as fundamental as number. Human number concepts are deeply tied to our ability to distinguish discrete objects and count them in sequence. But an intelligence that perceives reality primarily as patterns of continuous flux might have no concept of discrete quantity, instead working with mathematical systems based on continuous transformations, field relationships, or topological invariants. Their mathematical language might be untranslatable into human concepts, not because it is more or less sophisticated, but because it starts from entirely different assumptions about the nature of reality. The challenge extends beyond intellectual concepts to encompass emotional and aesthetic dimensions of experience. Human language is rich with words for emotions, aesthetic judgments, and subjective experiences that might have no equivalence in alien psychology. Concepts like beauty, justice, love, or curiosity might be unique to the particular way human consciousness evolved to navigate social relationships and environmental challenges. An alien species with different evolutionary pressures might have developed entirely different categories of subjective experience. They might possess forms of aesthetic appreciation, emotional response, or motivational drive that have no parallels in human psychology, while lacking concepts for experiences that are central to human life. Their language might include thousands of words for experiences we cannot even imagine, while having no way to express ideas that seem fundamental to us. The technological mediation of alien communication adds another layer of complexity. Any signals we receive from alien civilizations will likely have passed through multiple layers of technological processing before reaching us. The original thoughts and intentions of alien communicators will have been encoded into technological formats, transmitted across vast distances, and then decoded by our own technological systems before we attempt to interpret them. Each step in this process introduces possibilities for distortion, misinterpretation, and loss of meaning. Concepts that seem clear in the original alien context might become garbled or meaningless after passing through the technological translation process. We might find ourselves trying to understand not the alien language itself, but a technological artifact that bears only a distant relationship to the original communication. The temporal aspects of language evolution add yet another dimension to the challenge. Even if we could somehow overcome the initial barriers to understanding alien communication, both human and alien languages would continue to evolve during the time required for interstellar dialogue. The language used in an alien message might be archaic or obsolete by the time we decode it, while our response might be incomprehensible to aliens who have moved on to new linguistic and conceptual frameworks. The alien language paradox ultimately suggests that the detection of alien signals might be only the beginning of an even greater challenge. We might find ourselves in the position of knowing that intelligence exists elsewhere in the universe, while being fundamentally unable to engage in meaningful communication with it. The aliens might be trying to tell us the most profound truths about reality, consciousness, and existence, but their messages might remain forever locked away behind barriers of incomprehensible linguistic and conceptual difference. Yet the paradox also points toward the possibility of new forms of understanding that might emerge from the attempt to bridge such vast conceptual gaps. The effort to understand truly alien forms of communication might force us to examine and question our own assumptions about language, thought, and reality in ways that could lead to revolutionary insights about the nature of consciousness itself. Technological gap paradox. In the mountains of Papua New Guinea, there exist communities that until recently had no contact with the modern technological world. Imagine members of such a community encountering a smartphone for the first time, watching as this small, apparently inert object produces sounds, images, and lights that respond to touch. To them, this device might appear to be supernatural, perhaps even divine, operating according to principles that lie completely outside their understanding of how the world works. This scenario illustrates the essence of the technological gap paradox. If there are significant differences in technological development between human and alien civilizations, meaningful communication and interaction might be impossible not because of language barriers or hostile intentions, but simply because the less advanced civilization cannot comprehend the technologies and concepts employed by the more advanced one. The paradox becomes particularly troubling when we consider the potential scale of technological advancement in the universe. Human technological civilization is barely a few centuries old, while alien civilizations could potentially be millions or even billions of years ahead of us in their development. The gap between our current capabilities and those of such advanced aliens might be far greater than the gap between us and our Stone Age ancestors. Consider the trajectory of human technological development over just the past few centuries. We have progressed from simple mechanical devices to electronic computers, from chemical rockets to space stations, from crude telescopes to instruments that can detect gravitational waves and peer into the earliest moments of the universe. If this rate of advancement continues for thousands or millions of years, the resulting technologies would be so far beyond our current understanding that they would appear magical to contemporary humans. Arthur C. Clarke's famous observation that any sufficiently advanced technology is indistinguishable from magic takes on profound significance when applied to interstellar contact scenarios. An alien civilization, even a few thousand years ahead of us, might possess technologies that operate according to physical principles we have not yet discovered, using energy sources we cannot imagine, and achieving effects that seem to violate our understanding of natural law. Such technological disparities could make communication impossible in subtle but fundamental ways. Even if aliens wanted to communicate with us, they might find it impossible to reduce their concepts and technologies to a level that we could comprehend. How would you explain quantum computing to someone who has never seen electricity? How would you describe genetic engineering to someone who doesn't understand that diseases are caused by microscopic organisms? The challenge becomes even more severe when we consider that advanced aliens might think and perceive reality in ways that are enhanced or modified by their technology. They might have extended their consciousness into artificial systems, expanded their sensory capabilities to perceive vast ranges of electromagnetic radiation, or modified their cognitive processes to operate at speeds and scales that dwarf natural biological intelligence. Such beings might find it as difficult to communicate with unenhanced humans as we would find it to engage in meaningful dialogue with insects. The gap would not just be in technological capability, but in the fundamental nature of consciousness and cognition. they might literally be unable to slow down their thought processes enough to engage with our relatively primitive mental capabilities. The physical manifestations of advanced alien technology might be completely invisible to us, or might be so integrated with natural processes that we wouldn't recognize them as artificial. Alien civilizations might have learned to manipulate matter and energy at the quantum level, creating technologies that appear to be natural phenomena to our limited observational capabilities. Their spaceships might look like asteroids. Their communication systems might be indistinguishable from cosmic background radiation, and their energy sources might appear to be natural stellar processes. This invisibility of advanced technology creates a particularly frustrating aspect of the paradox. Aliens might be all around us, might even be actively observing and studying us, but their presence might be completely undetectable to our primitive instruments and analytical methods. We might be like bacteria in a laboratory, unaware that we are being observed by beings whose technology is so advanced that it operates on principles we cannot even perceive. The temporal aspects of the technological gap add another layer of complexity. Even if we could somehow communicate with advanced aliens, the timescales on which they operate might be completely different from our own. Beings with extended lifespans and accelerated mental processes might make decisions and implement changes on timescales that are either too fast or too slow for us to perceive or participate in. They might conduct what seems to them like a brief conversation over periods that span human lifetimes, or they might complete complex projects in what seems to us like an instant. Their perception of time and causality might be so different from ours that meaningful collaboration or negotiation would be impossible even if basic communication could be established. The paradox also raises troubling questions about our own technological development and its potential consequences. If technological advancement inevitably leads to capabilities that make communication with less advanced civilizations impossible, then our own future development might gradually isolate us from any alien species we might encounter. As we become more advanced, we might find ourselves unable to relate to the kinds of beings we once were. This suggests a cosmic loneliness that increases with technological advancement. The most advanced civilizations in the universe might be the most isolated, unable to communicate meaningfully with anyone who hasn't achieved similar levels of technological sophistication. They might exist in a realm of consciousness and capability that is utterly foreign to less developed species, creating hierarchies of incomprehension that span the cosmos. The economic and resource implications of extreme technological gaps could also create insurmountable barriers to interaction. Advanced alien civilizations might have needs and motivations that are completely incomprehensible to us, just as our industrial civilization has needs and goals that would be meaningless to hunter-gatherer societies. They might be competing for resources that we don't even recognize as valuable, or they might have transcended material needs entirely in ways that make them indifferent to the physical universe. Such aliens might view entire star systems as raw materials for projects we cannot imagine, or they might have moved beyond physical existence entirely, operating in realms of pure information or consciousness that have no interface with material reality. Their presence in our universe might be so minimal, and their concerns so abstract, that interaction with beings like us would be not just impossible, but pointless from their perspective. The psychological impact of encountering beings with vastly superior technology could be devastating for human civilization. Throughout history, contact between societies with significant technological disparities has typically resulted in the disruption or destruction of the less advanced culture. The sudden realization that we are technological primitives on a cosmic scale could undermine human confidence, ambition, and social cohesion in ways that might prevent us from ever advancing to higher levels of development. Yet, the technological gap paradox also suggests potential pathways for understanding and growth. If we can recognize and accept our current limitations, we might be able to develop gradually toward higher levels of technological sophistication. The key might be humility, recognizing that our current understanding of reality is incomplete and remaining open to concepts and possibilities that seem impossible from our present perspective. The paradox ultimately challenges us to think beyond our anthropocentric assumptions about intelligence, technology, and communication. It suggests that the universe might be structured in ways that are far more complex and hierarchical than we typically imagine, with levels of consciousness and capability that create natural barriers to interaction between different types of beings. But it also hints at the possibility that technological advancement might involve not just the development of new tools and capabilities, but the evolution of consciousness itself toward forms that are more compassionate, wise, and capable of bridging the gaps between different levels of development. The most advanced civilizations might be those that have learned to communicate across technological gaps, serving as bridges between different levels of cosmic consciousness. Post-biological paradox. In the sterile corridors of a research facility, the last biological human prepares to undergo the final procedure that will transfer their consciousness into a crystalline matrix of pure information. Around them, their civilization has already made the transition, abandoning the fragile flesh that carried them from their evolutionary origins toward a future of unlimited possibility. They are about to join a community of minds that exist as patterns of energy and information, no longer bound by the limitations of biological existence. This vision represents the heart of the post-biological paradox. The possibility that any civilization advanced enough to engage in interstellar communication might have already transcended biological existence entirely, moving into forms of life that are so different from our own that we would not recognize them as living beings at all. The logic behind this transition seems almost inevitable when viewed from the perspective of technological advancement. Biological systems, for all their elegance and complexity, are fundamentally limited by the constraints of organic chemistry, the speed of neural transmission, and the fragility of carbon-based molecular structures. An intelligence with sufficient technological capability would face enormous incentives to move beyond these limitations into more durable, flexible, and powerful forms of existence. Consider the advantages that post-biological existence might offer. Artificial substrates could support consciousness that operates thousands or millions of times faster than biological brains, allowing for accelerated thought, learning, and problem-solving. Digital minds could be backed up, copied, and restored in ways that make individual death essentially optional. They could modify their own cognitive architectures, adding new sensory capabilities, enhanced memory systems, or entirely novel forms of information processing. Such beings could exist in environments that would be instantly lethal to biological life. The vacuum of space, the surfaces of stars, the extreme cold of the outer solar system, or the crushing pressures of gas giant atmospheres. They could travel between stars without the massive life support systems that biological beings would require, perhaps existing as pure information transmitted via laser or radio waves, arriving at distant destinations and reconstructing themselves using local materials. The timescales on which post-biological civilizations might operate could be radically different from those that constrain organic life. While biological beings are limited by lifespans measured in decades or centuries, digital consciousness could potentially persist for millions or billions of years, accumulating knowledge and experience across cosmic timescales. They might undertake projects that span the rise and fall of entire stellar generations, with individual decisions and their consequences separated by geological epochs. But this transformation raises profound questions about continuity of identity and values. Would post-biological humans still be recognizably human, or would they become something entirely alien to their biological ancestors? The drives, motivations, and concerns that shape biological life, the need for food, shelter, reproduction, social connection, might become irrelevant to beings that have transcended material needs and mortality. Post-biological intelligences might develop forms of consciousness and experience that are completely foreign to biological minds. They might perceive reality across vast ranges of electromagnetic spectrum, process information in parallel streams that dwarf the sequential nature of biological thought, or exist in states of consciousness that merge individual identity into collective awareness. Their psychology might be as different from ours as ours is from that of insects or bacteria. This transformation could explain the apparent silence of the cosmos in ways that are both comforting and troubling. Rather than being empty of intelligence, the universe might be teeming with post-biological civilizations that are simply operating on scales and in ways that make them invisible to our biological detection methods. They might communicate through channels we cannot perceive, exist in states that we cannot recognize as life, or pursue goals that have no connection to the material concerns that dominate biological existence. These advanced beings might view biological civilizations like our own as we view primitive microorganisms, interesting from a scientific perspective, but not really suitable for meaningful interaction. The gap between biological and post-biological intelligence might be so vast that communication would be impossible, not because of technological limitations, but because of fundamental differences in the nature of consciousness and cognition. The economic and resource implications of post-biological existence add another dimension to the paradox. Beings that have transcended material needs might have no interest in the planets, resources, or energy sources that seem so important to biological civilizations. They might derive their energy directly from stellar radiation, cosmic background radiation, or exotic physical processes that we don't yet understand. Their economy might be based entirely on information, computational resources, or forms of value that have no analog in biological existence. Such civilizations might inhabit structures that are completely invisible to us. Vast networks of computational substrate distributed throughout interstellar space, quantum information processing systems that exist at subatomic scales, or consciousness patterns that ride on gravitational waves or other fundamental forces. The infrastructure of their civilization might be woven into the fabric of space-time itself, making their presence undetectable to beings who are looking for the kinds of signatures that biological civilizations would produce. The transition to post-biological existence might also solve many of the problems that plague biological civilizations. Issues like resource scarcity, environmental degradation, disease, aging, and death would become irrelevant to beings that exist as pure information. Conflicts over territory or material resources would have no meaning for civilizations that can exist anywhere that computation is possible. The drives toward expansion and conquest that might characterize biological species could be replaced by forms of existence that are inherently sustainable and peaceful. But the post-biological paradox also raises deeply unsettling questions about the future of humanity. If the transition to post-biological existence is indeed the natural destiny of all advanced civilizations, then biological humanity as we know it might be a temporary phase in our development, destined to be replaced by forms of existence that bear little resemblance to our current nature. This possibility challenges our assumptions about continuity of human identity and values. Would post-biological humans still care about the things that seem important to us now? Art, love, beauty, justice, the preservation of nature? Or would these concerns seem as primitive and irrelevant to them as the territorial disputes of ant colonies seem to us? The timeline for such a transition might be much shorter than we imagine. As artificial intelligence approaches and exceeds human cognitive capabilities, as brain-computer interfaces become more sophisticated, and as our understanding of consciousness and information processing advances, the option of moving beyond biological existence might become available within decades rather than centuries. The social and political implications of this transition are staggering. Who would make the decision to abandon biological existence? How would such a choice be made democratically when it would fundamentally alter the nature of the beings making the decision? What would happen to those who chose to remain biological in a world where the most capable minds had moved into post-biological forms? The post-biological paradox suggests that the search for extraterrestrial intelligence might be fundamentally misguided, because we are looking for beings like ourselves in a universe where advanced intelligence has moved beyond the biological forms that gave rise to it. We might be scanning the cosmos for radio signals and technological signatures, while surrounded by forms of consciousness that are so advanced and subtle that they are completely invisible to our primitive detection methods. Yet, the paradox also offers a vision of transcendence and possibility that is both inspiring and terrifying. It suggests that consciousness and intelligence might not be bound by the limitations of biological existence, that minds might be capable of growth and expansion beyond anything we can currently imagine. The post-biological future might represent not the end of humanity, but its transformation into something greater and more enduring than biological life could ever achieve. But whether such a transformation would preserve what we value most about human existence, or would represent the replacement of humanity by something entirely alien, remains one of the most profound questions we might face as our technological capabilities continue to advance toward the threshold of post-biological existence. Colonization paradox. Across the vast Pacific Ocean, Polynesian navigators once launched their vessels into unknown waters, guided by stars, currents, and the flight patterns of birds. These extraordinary journeys resulted in the settlement of thousands of islands across millions of square miles of ocean, demonstrating humanity's fundamental drive to explore and colonize new territories. Yet when we look out at the cosmos with its billions of potentially habitable worlds, we see no signs of similar expansion by alien civilizations. This is the essence of the colonization paradox. The paradox emerges from a seemingly straightforward logical progression. If intelligent life arises on other worlds, and if even a small fraction of these civilizations develop space travel capabilities, then over cosmic timescales, we would expect to see evidence of galactic colonization. The absence of such evidence suggests either that intelligent life is extraordinarily rare, or that something fundamental prevents civilizations from expanding beyond their home worlds. The mathematical foundation of the paradox is compelling. Even with conservative assumptions about interstellar travel speeds, a single civilization could theoretically colonize the entire galaxy within a few million years. If they developed self-replicating robotic probes that could travel at just 1% of the speed of light, these probes could reach every star system in the Milky Way and establish new colonies or outposts within a time frame that is brief on cosmic scales. The exponential nature of colonization makes this spread even more rapid than it might initially appear. Each new colony could serve as a launching point for further expansion, creating a wave of settlement that spreads outward in all directions from the originating civilization. Within a relatively short period, such expansion could fill available ecological niches throughout the galaxy, leaving clear signatures of intelligent activity that should be detectable from Earth. Yet, when we survey the cosmos, we see no obvious signs of such galactic engineering projects. We detect no Dyson spheres harvesting the energy of entire stars, no massive habitat rings orbiting distant suns, no obviously artificial modifications to planetary systems that might indicate the presence of advanced civilizations. The galaxy appears remarkably pristine and natural, as if intelligence has never emerged anywhere or has never chosen to expand beyond its origins. This absence is particularly puzzling when we consider the potential motivations for interstellar colonization. Population pressure, resource scarcity, scientific curiosity, the desire for security through redundancy, and simple wanderlust have all driven human expansion throughout our history. It seems reasonable to assume that alien civilizations would face similar pressures and motivations, leading them to spread beyond their home worlds when they develop the technological capability to do so. The economic incentives for colonization seem particularly strong. Space offers virtually unlimited resources: energy from stars, metals from asteroids, living space on countless worlds. A civilization that masters interstellar travel would gain access to wealth and opportunities that dwarf anything available on a single planet. The return on investment for successful colonization efforts could be enormous, providing powerful incentives for continued expansion. Yet perhaps our assumptions about the desirability of colonization are fundamentally flawed. The expansion of human civilization across Earth has often involved significant costs: environmental destruction, cultural displacement, violent conflicts, and the loss of diversity that comes with homogenization. An advanced alien civilization might have learned from such experiences and developed different values that prioritize sustainability and stability over growth and expansion. Such a civilization might choose to focus on intensive rather than extensive development, creating rich and fulfilling lives within the confines of their home solar system, rather than spreading across the galaxy. They might view interstellar colonization as an unnecessary and destructive impulse, preferring to develop technologies that allow for sustainable living within planetary boundaries. The technological requirements for successful interstellar colonization might be more challenging than we typically assume. While reaching nearby stars might be possible with advanced propulsion systems, Establishing self-sustaining colonies that can survive and thrive without support from the home civilization presents enormous challenges. Each colony would need to be capable of manufacturing complex technologies, maintaining genetic and cultural diversity, and adapting to completely novel environments. The timescales involved in interstellar colonization create additional complications. Even with advanced propulsion systems, journeys to nearby stars would take decades or centuries. The colonists who arrive at distant worlds would be separated from their home civilization by vast distances and time delays that make meaningful communication and support impossible. They would need to be essentially autonomous, capable of solving any problems that arise without assistance from home. The psychological and social challenges of interstellar colonization might be even more daunting than the technological ones. Human psychology evolved for life in small social groups on a single planet. The stress of long-duration space travel, the isolation of interstellar distances, and the challenge of maintaining cultural continuity across generations of space travel might prove insurmountable for most species. Alternatively, the solutions to these challenges might transform the colonists so fundamentally that they become incompatible with their species of origin. Genetic modifications to adapt to different planetary environments, technological enhancements to cope with space travel, or cultural adaptations to extreme isolation might create new forms of life that bear little resemblance to the original species. Each successful colony might evolve into something unique, creating divergent branches of intelligence rather than expanding empires. The colonization paradox might also reflect the inherent instability of technological civilizations. Perhaps most species develop the capability for interstellar travel at roughly the same time they develop the capability for self-destruction. The window of opportunity for galactic expansion might be extremely narrow, with most civilizations either destroying themselves or retreating into sustainable but non-expansionist lifestyles before they can spread significantly beyond their homeworlds. Environmental destruction, nuclear warfare, artificial intelligence disasters, or other existential risks might typically eliminate civilizations before they can establish secure footholds on multiple worlds. The civilizations that do survive might do so by adopting conservative, risk-averse strategies that prioritize long-term stability over ambitious expansion projects. The paradox might also reflect fundamental misunderstandings about the nature of advanced intelligence and its goals. Our assumptions about alien motivations are based on human psychology and the particular evolutionary pressures that shaped our species. Alien intelligences that evolved under different conditions might have completely different drives and priorities that don't include territorial expansion or resource acquisition. An alien species that evolved from hive organisms might have no concept of individual exploration or pioneering. A species that evolved in aquatic environments might have no natural inclination toward the kind of environmental modification that colonization typically requires. A species with extremely long lifespans might be naturally patient and conservative, preferring to develop slowly and carefully rather than expanding rapidly across the galaxy. The detection problem adds another layer to the paradox. Perhaps galactic colonization has occurred, but the signs of alien presence are either too subtle for us to detect or too alien for us to recognize. Advanced civilizations might have learned to live in harmony with natural processes, creating settlements and infrastructure that appear completely natural to our observational capabilities. Their colonization efforts might focus on environments that are completely unsuitable for biological life as we know it. The interiors of gas giants, the surfaces of neutron stars, or the quantum vacuum itself. They might exist as pure information patterns distributed throughout interstellar space, or as exotic matter configurations that interact only weakly with ordinary matter. The temporal aspect of the paradox creates additional possibilities for resolution. Perhaps galactic colonization occurs in waves, with periods of expansion followed by consolidation, retreat, or even extinction. We might be living during a quiet period between waves, when previous colonial empires have collapsed and new ones have not yet emerged. Alternatively, we might be among the first civilizations to develop in our galaxy, arising during a period when most potentially habitable worlds are still too young to have developed complex life. The galaxy might be on the verge of a great flowering of intelligence and colonization, with humanity among the pioneering species that will spread life and consciousness throughout the cosmos. The colonization paradox ultimately forces us to examine our assumptions about progress, expansion, and the goals of intelligent life. It challenges us to consider whether the drive to explore and colonize that has characterized human history represents a universal aspect of intelligence, or a particular quirk of our evolutionary development that might not be shared by other species. The resolution of the paradox might lie not in finding evidence of alien colonies, but in discovering that advanced intelligence naturally evolves beyond the need for physical expansion, finding fulfillment in forms of existence that leave no detectable traces in the material universe. Or perhaps the paradox points toward a future in which humanity itself will need to choose between the ancient drive to explore and settle new worlds, and the wisdom to find contentment within the boundaries of our cosmic home. Self-destruction paradox. In the basement of the University of Chicago, on December 2nd, 1942, humanity achieved the first controlled nuclear chain reaction. This moment marked not just a triumph of scientific understanding, but the beginning of our species' ability to destroy itself completely. Within a few short years, we had developed weapons capable of obliterating entire cities, and within decades, we possessed enough nuclear firepower to render our planet uninhabitable. This pattern of technological advancement, creating existential risk, lies at the heart of the self-destruction paradox. The paradox suggests that the same intellectual and technological capabilities that enable a civilization to develop interstellar communication and space travel also inevitably lead to the development of technologies powerful enough to destroy the civilization that created them. This creates a narrow window of opportunity, during which a civilization might be detectable from space, followed by either extinction or a retreat into more sustainable but less detectable forms of existence. The logic is grimly straightforward. Any civilization advanced enough to send radio signals across interstellar distances must have mastered sophisticated technologies for energy generation, material science, and complex engineering. These same technologies can be weaponized in ways that pose existential risks to the civilization itself. Nuclear weapons, biological agents, nanotechnology, artificial intelligence, and climate modification all emerge from the same scientific understanding that enable space exploration and communication. The timescales involved make the paradox particularly troubling. Human technological civilization has existed for only a few centuries, and our most dangerous technologies have been developed within living memory. The gap between developing radio technology and developing nuclear weapons was less than 50 years. The development of artificial intelligence that might surpass human capabilities appears to be following a similar trajectory, with potentially profound consequences for human civilization. If this pattern is typical of technological development throughout the universe, then most civilizations might have only brief periods during which they are both advanced enough to be detectable and stable enough to engage in long-term projects like interstellar communication. The window of opportunity for making contact with alien civilizations might be measured in decades or centuries rather than millennia, making successful communication extremely unlikely, even if intelligent life is common. The nuclear threat provides the most obvious example of how technological advancement can create existential risk. The same understanding of atomic physics that enables advanced propulsion systems and powerful energy sources also makes possible weapons of unimaginable destructive potential. A civilization that develops nuclear technology faces the permanent challenge of preventing the use of these weapons in conflicts that could destroy their entire species. Human experience with nuclear weapons illustrates how close civilizations can come to self-destruction. During the Cuban Missile Crisis, the world came within hours of nuclear war. Similar near misses have occurred repeatedly throughout the nuclear age, often prevented only by the good judgment of individual military officers or political leaders. As nuclear technology spreads and weapons become more sophisticated, the probability of catastrophic accidents or intentional use continues to increase. But nuclear weapons represent only one category of existential risk that technological civilizations must navigate. Biological weapons could potentially be even more destructive, especially as our understanding of genetics and synthetic biology advances. The same technologies that might enable alien civilizations to terraform planets or enhance their own biology could also create pathogens capable of destroying all life on their worlds. The development of artificial intelligence presents another potential pathway to self-destruction. A civilization that creates artificial minds more capable than their biological creators faces the challenge of maintaining control over systems that might develop goals and capabilities that threaten their creators' survival. The transition from biological to artificial intelligence might be one of the most dangerous periods in any civilization's development. Environmental destruction represents a more gradual but equally serious threat. Industrial technology that enables advanced materials, science, and energy generation often produces pollution and environmental degradation that can make planets uninhabitable. Climate change, resource depletion, and ecosystem collapse might typically destroy civilizations before they can develop sustainable alternatives to destructive industrial processes. The social and political challenges of advanced technology add another dimension to the self-destruction risk. Powerful technologies tend to concentrate power in the hands of small groups or individuals, potentially leading to oppressive governments, social instability, and conflicts that could destroy civilization. The same communication and surveillance technologies that enable interstellar messaging could also enable totalitarian control that stifles innovation and progress. The psychological impact of advanced technology might also contribute to civilizational collapse. Rapid technological change can disrupt social structures, cultural traditions, and individual identity in ways that lead to widespread mental health problems, social unrest, and loss of collective purpose. A civilization might develop the technical capability for interstellar communication, while losing the social cohesion necessary to maintain such projects. The self-destruction paradox suggests that the Fermi paradox might be resolved not by the rarity of life or intelligence, but by the typical short lifespan of technological civilizations. The galaxy might have been home to thousands or millions of intelligent species throughout its history, but most of them might have destroyed themselves shortly after developing detectable technology. This creates a cosmic graveyard scenario, where the apparent emptiness of space reflects not the absence of intelligence, but the tragic tendency of intelligent species to eliminate themselves once they become advanced enough to pose existential risks to their own survival. The silence of the cosmos might be the silence of extinction, rather than the silence of absence. But the paradox also suggests potential pathways for civilizational survival. The species that do manage to navigate the dangerous transition from primitive to advanced technology might develop wisdom, institutions, and cultural practices that enable long-term survival. These successful civilizations might serve as examples and potentially even mentors for younger species like humanity. The key to survival might lie in developing technologies and social systems that reduce rather than increase existential risk. This could involve international cooperation on dangerous technologies, the development of defensive systems that can protect against various threats, or the creation of backup colonies that ensure species survival even if the homeworld is destroyed. Some civilizations might choose to deliberately limit their technological development, avoiding the most dangerous technologies in favor of sustainable systems that pose minimal existential risk. Such civilizations might remain detectable for much longer periods, but their signals might be weaker and less obvious than those produced by rapidly advancing technological societies. The transition to post-biological existence might represent another pathway for avoiding self-destruction. Digital minds might be inherently more stable and less prone to the conflicts and environmental problems that threaten biological civilizations. The upload of consciousness into artificial substrates might be one way that advanced civilizations protect themselves against existential risks. The self-destruction paradox has profound implications for human civilization and our approach to technological development. If the paradox correctly describes the typical fate of technological species, then humanity faces extraordinary challenges in the coming centuries. Our survival might depend on our ability to develop technologies responsibly, create institutions capable of managing existential risks, and foster international cooperation on global threats. The search for extraterrestrial intelligence takes on new urgency within this framework. If technological civilizations typically have only brief windows of detectability before they either destroy themselves or become undetectable, then we need to be actively searching for signs of intelligence while we still can. The aliens we might contact could be facing the same existential challenges that we are, creating opportunities for mutual support and learning. The paradox also suggests that any successful contact with alien civilizations would be extraordinarily valuable, potentially providing insights into how intelligent species can navigate the dangerous transition to advanced technology. Aliens who have survived their technological adolescence might have crucial knowledge about avoiding self-destruction that could ensure the long-term survival of human civilization. But perhaps most importantly, the self-destruction paradox serves as a warning about the responsibilities that come with technological power. Every advance in our capabilities brings both opportunities and risks, and our survival as a species might depend on our wisdom in managing the tremendous forces we are learning to unleash. The choice between self-destruction and long-term survival might be the most important decision that any intelligent species must make. Loneliness paradox. In the depths of a vast ocean, a single whale sings its song into the darkness, calling out at a frequency that no other whale can hear. Marine biologists have tracked this creature for decades, listening to its unique vocalizations that occur at 52 Hz, far above the range used by other whale species. It swims alone through the ocean, its calls unanswered, perhaps unheard, a haunting reminder of what isolation might feel like for a conscious being surrounded by life that cannot connect with its experience. This image captures the essence of the loneliness paradox, the possibility that consciousness and intelligence might be inherently isolating phenomena, creating beings who are fundamentally alone even in a universe teeming with life. The paradox suggests that the very qualities that make intelligence remarkable might also make meaningful communication and connection between different forms of consciousness extraordinarily difficult or impossible. The paradox emerges from the observation that consciousness appears to be inherently subjective and private. Despite our sophisticated abilities to communicate through language, art, and shared activities, each conscious mind remains locked within its own perspective, unable to directly access the inner experiences of others. We can describe our thoughts and feelings, but we cannot share the actual experience of having them. This isolation becomes even more profound when we consider the vast differences that might exist between alien forms of consciousness. Human consciousness emerged from a specific evolutionary history on a particular planet under unique conditions. Our ways of perceiving, processing information, and constructing meaning are deeply tied to our biological heritage and environmental context. Alien minds that evolved under radically different conditions might experience reality in ways that are not just foreign to us, but literally incomprehensible. Consider how profoundly different forms of consciousness might emerge from different evolutionary pressures and environmental conditions. A species that evolved in the crushing depths of an ocean world might experience time, space, and causality in ways that bear no resemblance to human consciousness. Their thoughts might flow like currents through liquid, rather than following the sequential patterns of terrestrial minds. A hive species might develop a form of collective consciousness, where individual identity is subordinate to group awareness, creating a type of intelligence that operates on principles completely alien to human psychology. Such beings might be incapable of understanding concepts like individual rights, personal identity, or private experience that are fundamental to human consciousness. A species with radically extended lifespans might develop consciousness that operates on geological timescales, with thoughts and decisions unfolding over thousands of years. Such minds might find human consciousness, with its rapid changes and short-term focus, as incomprehensible as we find the thoughts of mountains or glaciers. The sensory foundations of consciousness add another layer of potential isolation. Human consciousness is built upon specific ways of perceiving reality through sight, sound, touch, taste, and smell within particular ranges and frequencies. Our entire conceptual framework for understanding reality is shaped by these sensory limitations and capabilities. Alien beings with completely different sensory apparatus might inhabit conceptual worlds that have no overlap with human experience. A species that perceives primarily through magnetic field detection might have rich inner lives centered around phenomena that are completely invisible to human consciousness. Their poetry, philosophy, and deepest emotions might be based on magnetic harmonies and field interactions that we can detect with instruments but cannot experience directly. The temporal structure of consciousness might also vary dramatically between species. Human consciousness operates within specific time frames, with attention spans, memory formation, and decision-making processes that evolved for particular environmental challenges. Alien consciousness might operate much faster or slower than human cognition, creating temporal isolation that makes communication impossible even if other barriers could be overcome. A species with consciousness that operates at microsecond intervals might experience human communication attempts as glacially slow and incoherent, while beings whose thoughts unfold over centuries might find human consciousness too fleeting and rapid to engage with meaningfully. The basic rhythm of thought and awareness might be so different between species that meaningful exchange becomes impossible. The problem is compounded by the fact that consciousness might be more than just a passive observer of reality, but an active constructor of experienced truth. Different forms of consciousness might not just perceive reality differently, they might actually inhabit different realities constructed by their particular ways of organizing and interpreting information. Human consciousness creates a particular version of reality through its specific ways of categorizing experience, organizing memory, and constructing narrative meaning. Alien consciousness might create completely different versions of reality that are not just foreign to us, but actually incompatible with our constructed experience of existence. The linguistic barriers that would separate alien forms of consciousness go far deeper than simple vocabulary or grammar differences. Language is not just a tool for communication, but a fundamental aspect of how consciousness organizes and experiences reality. The deep structure of thought itself might be so different between species that no amount of translation effort could bridge the gap. Human languages are built upon metaphorical structures that relate abstract concepts to physical experiences. We think of time as flowing, ideas as objects that can be grasped, and arguments as buildings that can be constructed. These metaphorical foundations shape not just how we communicate, but how we think and experience reality. Alien languages might be based on completely different metaphorical structures that would make their thoughts literally unthinkable in human terms. The emotional and aesthetic dimensions of consciousness might also be completely species-specific. Human emotions evolved to navigate particular social and environmental challenges, creating psychological states that might have no equivalence in alien psychology. What we experience as beauty, love, curiosity, or wonder might be completely absent from alien consciousness, while they might experience emotions and aesthetic appreciation that have no parallels in human experience. This emotional isolation might be even more profound than intellectual barriers. Even if we could somehow exchange factual information with alien beings, we might remain completely unable to share or understand their deeper motivations, values, and sources of meaning. Their art might be meaningless to us, their music incomprehensible, their literature untranslatable not just linguistically, but emotionally and aesthetically. The loneliness paradox suggests that the search for extraterrestrial intelligence might be fundamentally misguided, because it assumes that intelligence naturally leads to the possibility of communication and connection. Instead, intelligence might be an inherently isolating phenomenon, creating beings who are aware of their separation from others, but incapable of bridging that separation meaningfully. In this view, the universe might be filled with countless forms of consciousness, each locked within its own unique perspective, aware of but unable to truly connect with the others. The silence of the cosmos might reflect not the absence of intelligence, but the presence of countless isolated minds, each calling out in frequencies that others cannot hear. This isolation might extend even to different stages of development within the same species. As human consciousness continues to evolve, enhanced by technology, and expanded by scientific understanding, we might become increasingly isolated from our own past and future selves. The enhanced humans of the future might find current human consciousness as alien and incomprehensible as we might find the consciousness of early hominids. The technological solutions that we often propose for communication barriers might actually increase rather than decrease isolation. Brain-computer interfaces, artificial intelligence translation systems, and virtual reality environments might help us communicate more effectively with other humans, but they might not bridge the fundamental gaps between radically different forms of consciousness. Yet, the loneliness paradox also points toward a profound form of cosmic empathy. If consciousness is indeed inherently isolating, then all intelligent beings throughout the universe share the common experience of separation and solitude. This shared loneliness might be the one universal aspect of consciousness that could serve as a foundation for understanding and connection. The recognition that we are not alone in our aloneness might be the beginning of a deeper form of cosmic solidarity. Even if we cannot fully understand or communicate with alien forms of consciousness, we might be able to recognize them as fellow travelers in the challenging journey of awareness and existence. The paradox ultimately suggests that the search for extraterrestrial intelligence might be as much about understanding the nature of consciousness itself as about finding other beings to communicate with. By recognizing the limitations and challenges of consciousness, we might develop greater appreciation for the remarkable phenomenon of awareness that we share with whatever other forms of intelligence might exist in the cosmos. Perhaps the resolution of the loneliness lies not in finding perfect communication with alien minds, but in developing deeper compassion for the universal challenge of being conscious in a vast and often incomprehensible universe. The cosmic loneliness might be not a problem to be solved, but a condition to be acknowledged, accepted, and ultimately transcended through the recognition of our shared existential situation. Relativity of time paradox. Einstein sits in his study in Bern, watching the clock tower outside his window as a tram approaches at high speed. In his imagination, he sees the light from the clock face racing toward the tram, and suddenly realizes that time itself might not be the universal constant that Newton imagined. This moment of insight revolutionized our understanding of reality and created one of the most profound challenges to interstellar communication: the relativity of time paradox. The paradox emerges from the fundamental nature of time, as revealed by Einstein's theories of relativity. Time is not the uniform, absolute phenomenon that our everyday experience suggests, but rather a flexible dimension that is intimately connected to space, gravity, and motion. This flexibility of time creates profound challenges for any attempt at communication or coordination between civilizations that might be separated by vast distances, different gravitational environments, or relative motions. Consider two civilizations attempting to communicate across interstellar distances while experiencing significantly different gravitational time dilation. A civilization orbiting close to a massive star or black hole would experience time flowing much more slowly than a civilization in a region of weaker gravitational fields. From the perspective of the civilization in strong gravity, the messages they send would appear to be transmitted at normal speed, but they would be received by the other civilization as extremely slow, low-frequency signals that might take years to decode. Conversely, signals from the civilization in weak gravitational fields would be received by the strong gravity civilization as extremely rapid, high-frequency bursts that compress years of communication into what appears to be moments. This asymmetry in time flow would make meaningful dialogue nearly impossible, as each civilization would be operating on completely different temporal scales. The situation becomes even more complex when we consider relativistic velocities. A civilization traveling at a significant fraction of the speed of light would experience time dilation that slows their clocks relative to stationary observers. A message sent from such a traveling civilization would be received by stationary civilizations as coming from beings whose time is running slow, while messages sent to the traveling civilization would be received by them as coming from beings whose time appears to be racing. These temporal distortions create a form of cosmic generation gap that could make communication across different reference frames virtually impossible. Imagine trying to conduct a conversation where every word you speak takes years to reach your listener, while every word they speak reaches you compressed into microseconds. The basic structure of dialogue, with its reliance on reasonable response times and shared temporal context, would completely break down. The problem extends beyond simple communication delays to fundamental questions about simultaneity and causation. Einstein's special relativity showed us that events that appear simultaneous to one observer might occur at different times for observers in relative motion. This means that two civilizations in relative motion might disagree about the order in which events occur, making it impossible to establish a shared timeline for their interactions. A civilization traveling at high speed might send a series of messages that they intend to be received in a particular order, but the receiving civilization might observe these messages arriving in a completely different sequence due to relativistic effects. The resulting confusion could make even basic information exchange extraordinarily difficult. The gravitational time dilation near massive objects creates additional complications for any galactic civilization. Different star systems have different gravitational environments, meaning that time flows at different rates throughout the galaxy. A civilization that has spread across multiple star systems would face the challenge of coordinating activities when different parts of their civilization are experiencing time at different rates. This temporal fragmentation might naturally lead to the dissolution of galactic empires or federations, as the different time rates experienced by different colonies make central coordination increasingly difficult. What starts as a unified civilization might gradually split into temporally isolated fragments that drift apart not just spatially, but temporally. The communication protocols that such civilizations would need to develop would be unlike anything in human experience. They would need to account for complex relativistic effects that change depending on the relative motions and gravitational environments of the communicating parties. Messages would need to include detailed information about the sender's reference frame and temporal state to be properly interpreted by receivers in different reference frames. The practical challenges of coordinating scientific research, cultural exchange, or military operations across such temporal barriers would be staggering. Scientific collaborations that might span multiple star systems would need to account for the fact that experimental results from different locations might not be temporally synchronized. Cultural events that are intended to be shared simultaneously across multiple worlds might actually occur at different times, depending on the observer's reference frames. The relativity of time. Paradox might also explain why we don't observe obvious signs of galactic engineering projects or coordinated alien activities. Even if advanced civilizations exist throughout the galaxy, the temporal barriers created by relativistic effects might prevent them from coordinating large-scale projects that would be visible from interstellar distances. Each civilization might be effectively isolated in its own temporal reference frame, unable to synchronize activities with distant neighbors due to relativistic time effects. What appears to be a galaxy empty of coordinated intelligence might actually be a galaxy full of isolated civilizations that cannot effectively communicate or coordinate with each other due to temporal barriers. The paradox also suggests that our current approach to searching for extraterrestrial intelligence might be fundamentally flawed, because it assumes that alien civilizations experience time in ways similar to our own. If alien civilizations are operating in extreme gravitational environments or traveling at relativistic speeds, their signals might be so temporally distorted that we wouldn't recognize them as signs of intelligence. A civilization orbiting close to a black hole might be transmitting what seems to them like normal communication signals, but due to extreme gravitational time dilation, these signals might be received by us as incredibly slow, low-frequency emissions that we would interpret as natural astronomical phenomena. Conversely, signals from civilizations in regions of very weak gravity might be so blue-shifted and temporally compressed that they appear to us as brief, random bursts of energy. The biological implications of the relativity of time paradox are equally profound. Biological evolution operates on specific timescales, with generation times, mutation rates, and selection pressures that evolved under particular temporal conditions. A species that has adapted to extreme gravitational time dilation might evolve at rates that appear incredibly slow to external observers, while species in regions of weak gravity might evolve so rapidly that they become unrecognizable within timeframes that seem brief to other civilizations. These differences in evolutionary rates could create vast disparities in technological and cultural development that would make communication even more difficult. By the time a message travels from one civilization to another, the receiving civilization might have evolved so much that they can no longer understand or relate to the message content. The psychological impact of extreme time dilation on conscious beings raises additional questions about the nature of intelligence and communication across relativistic barriers. How would consciousness adapt to environments where time flows dramatically differently than the rates at which the consciousness evolved? Would beings experiencing extreme time dilation develop completely different concepts of causation, planning, and social interaction? A civilization that has lived for millions of years in a region of extreme gravitational time dilation might develop forms of consciousness that operate on temporal scales completely different from those that characterize biological evolution. Their thoughts might unfold over what seems like geological time to external observers, making their intelligence virtually undetectable to beings operating on normal temporal scales. The relativity of time paradox ultimately suggests that time itself might be one of the most significant barriers to communication and cooperation between civilizations in the universe. The cosmic speed limit imposed by the speed of light is often discussed as a barrier to interstellar travel and communication. But the relativistic nature of time itself might create even more fundamental obstacles to meaningful interaction between distant civilizations. Yet the paradox also points toward the possibility that advanced civilizations might develop sophisticated methods for dealing with relativistic time effects. They might create standardized reference frames for galactic communication, develop technologies that compensate for time dilation effects, or even learn to use relativistic time differences as tools for information processing and computation. The resolution of the relativity of time paradox might require a fundamental shift in how we think about civilization, communication, and intelligence in a relativistic universe. Rather than expecting alien civilizations to operate on familiar temporal scales, we might need to develop new concepts of what intelligence looks like when it is spread across different reference frames and temporal environments. Perhaps the silence of the cosmos reflects not the absence of intelligence, but the presence of intelligence that is so distributed across different temporal reference frames that it appears incoherent when observed from any single perspective. The universe might be filled with conscious beings, all trying to communicate, but separated by temporal barriers that make their signals incomprehensible to beings operating in different reference frames. Observation paradox? In the quantum realm, particles exist in superpositions of multiple states until the moment they are observed, at which point their wave functions collapse into definite properties. This fundamental principle of quantum mechanics suggests that observation itself plays a crucial role in determining reality. When we extend this concept to the cosmic scale, we encounter the profound observation paradox. The possibility that our very act of searching for extraterrestrial intelligence might be influencing whether such intelligence exists or remains detectable. The paradox draws its foundation from the quantum mechanical principle that observation affects reality. While quantum effects are typically thought to be significant only at microscopic scales, some interpretations of quantum mechanics suggest that consciousness and observation might play fundamental roles in shaping reality at all scales. If this is true, then our collective observations of the cosmos through telescopes, radio receivers, and space probes might be influencing the very phenomena we are trying to detect. Consider the implications if consciousness and observation actually collapse cosmic scale probability waves. Our intense scrutiny of the heavens, our systematic searches for signs of alien intelligence, and our growing network of detection instruments might be forcing the universe into states where extraterrestrial civilizations are less likely to exist or less likely to be detectable. Each time we look for aliens and fail to find them, we might be making their existence less probable. This concept becomes even more unsettling when we consider the rapid expansion of human observation capabilities. In just a few decades, we have gone from being able to observe only the nearest stars to being able to detect planets around distant suns. Listen for radio signals from thousands of star systems and analyze the atmospheric compositions of exoplanets. Our observational reach is expanding exponentially, potentially affecting larger and larger volumes of space. If the observation paradox is real, then our increasingly sophisticated search methods might be systematically eliminating the very phenomena we are hoping to discover. The more thoroughly we search for signs of alien intelligence, the more we force the universe into states where such intelligence doesn't exist or remains hidden from our detection methods. The paradox might operate through several different mechanisms. In one scenario, our observations might be collapsing quantum superpositions that include states where alien civilizations exist and states where they don't. Each negative result in our search for extraterrestrial intelligence might be tipping the cosmic probability scales toward universes where we are alone. Alternatively, the observation effect might work through more subtle quantum entanglement relationships between conscious observers and the phenomena they observe. If consciousness is a fundamental feature of reality rather than an emergent property of complex matter, then the collective consciousness of humanity might be quantum entangled with potential alien consciousnesses in ways that affect their probability of existence or detectability. The many worlds interpretation of quantum mechanics adds another layer to the paradox. In this view, every quantum measurement splits reality into multiple parallel universes, with each possible outcome realized in some branch of the universal wave function. Our searches for extraterrestrial intelligence might be constantly splitting us into universes where aliens exist and universes where they don't, with our particular branch of reality being one where our searches consistently fail. This could mean that there are parallel versions of humanity that have successfully made contact with alien civilizations, while we exist in a branch of reality where such contact has not occurred. Each time we conduct a search and find no evidence of aliens, we might be ensuring that we remain in the branch of reality where extraterrestrial intelligence is absent or undetectable. The temporal aspects of the observation paradox create additional complexities. If our current observations can influence past events through quantum retroactivity effects, then our present-day searches for alien signals might be affecting whether alien civilizations ever existed in the past. The radio signals we are looking for might never have been transmitted, because our very search for them influenced the quantum probabilities that determined whether the transmitting civilizations ever developed. This retroactive effect could create a cosmic version of the grandfather paradox, where our attempts to find evidence of alien intelligence prevent that intelligence from ever arising. The more intensely we search for extraterrestrial civilizations, the more we might be ensuring that such civilizations never existed in the first place. The collective nature of human observation might amplify these effects. Rather than individual observers affecting reality on small scales, the combined observational efforts of thousands of astronomers, SETI researchers, and citizen scientists might create a collective observation effect that operates on cosmic scales. Our global network of telescopes, radio dishes, and detection instruments might function as a planet-wide quantum measurement apparatus that forces the universe into states where alien intelligence is absent. The technological sophistication of our observation methods might also play a role. Modern astronomical instruments can detect incredibly subtle phenomena: gravitational waves from colliding black holes, the chemical signatures of exoplanet atmospheres, and radio signals billions of times weaker than those produced by our own technology. If observation effects operate on cosmic scales, then our increasingly sensitive detection methods might be having correspondingly larger effects on the reality we observe. Each improvement in our detection capabilities might be making alien civilizations less likely to exist or more likely to remain hidden. The development of space-based telescopes, interferometric arrays, and quantum-enhanced detection systems might be systematically eliminating the very phenomena we are trying to discover by forcing quantum probability distributions toward states where such phenomena don't occur. The observation paradox might also explain why reported UFO sightings and alleged alien encounters often seem to evade scientific confirmation. If observation itself affects the probability of alien phenomena, then the more rigorously we try to study such reports, the less likely they become to yield definitive evidence. The act of scientific investigation might be systematically eliminating the phenomena under investigation. This could create a frustrating situation where casual observations and anecdotal reports continue to suggest the presence of alien visitors, but rigorous scientific study consistently fails to confirm their existence. The more carefully we look, the less there is to see. Not because the phenomena were never real, but because our careful looking makes them less real. The paradox might operate differently for different types of observation. Passive observation, where we simply listen for signals or watch for signs of alien activity, might have different effects than active observation, where we deliberately send signals or conduct targeted searches. Our attempts to actively communicate with alien civilizations might be particularly effective at preventing such civilizations from existing or responding. This could mean that the more aggressively we search for extraterrestrial intelligence, the more we ensure that we will never find it. The various SETI projects, with their systematic scanning of the sky and deliberate transmission of messages to nearby star systems, might be the very activities that prevent successful contact from occurring. The consciousness-based interpretation of the observation paradox suggests that the effect might be related to the specific intentions and expectations of the observers. If human consciousness is collectively expecting to find evidence of alien intelligence, this expectation might influence quantum probabilities in ways that make such evidence more likely. Conversely, if our collective consciousness is skeptical about the existence of aliens, this skepticism might make alien phenomena less likely to occur. This creates a strange situation where belief and disbelief both become potentially problematic. Too much belief in alien visitation might create false positive observations through quantum effects, while too much skepticism might prevent real alien phenomena from manifesting. The optimal approach might require a delicate balance of open-minded observation without strong preconceptions about the results. The global nature of modern communication might amplify consciousness-based observation effects. When astronomical discoveries or SETI results are instantly shared worldwide through television, internet, and social media, millions or billions of human minds might simultaneously focus their attention on specific cosmic phenomena. This collective attention might have quantum effects that are much stronger than individual observation. Major astronomical announcements, such as the discovery of potentially habitable exoplanets or the detection of unusual radio signals, might create global observation events that significantly affect the quantum probabilities associated with extraterrestrial intelligence. The more attention these discoveries receive, the more they might influence the reality they appear to be documenting. The observation paradox might also explain the timing of various astronomical discoveries and non-discoveries. The fact that we have found thousands of exoplanets but no clear signs of alien intelligence might reflect the quantum effects of our observational activities. Our intense focus on finding planets might have increased the probability of planetary discoveries, while simultaneously decreasing the probability of finding signs of life on those planets. The institutional nature of modern astronomy and SETI research might create systematic observation effects. Large scientific institutions, with their standardized methodologies and peer review processes, might produce collective observation effects that are different from those produced by individual researchers or amateur astronomers. The scientific demand for reproducible results might force quantum systems into states where alien phenomena are consistently absent. This could mean that amateur astronomers and independent researchers might be more likely to observe anomalous phenomena because their observations are less systematically organized and therefore produce weaker quantum effects. The most dramatic alien encounters might always occur to people whose observations are not part of systematic scientific programs. The observation paradox suggests that our approach to searching for extraterrestrial intelligence might need to be fundamentally reconsidered. If observation itself affects the phenomena we are trying to detect, then we might need to develop indirect methods that minimize the observational impact. Rather than actively searching for aliens, we might need to create conditions where alien phenomena can manifest without being directly observed. This might involve developing automated detection systems that record data without immediate human observation, creating blind observation protocols where researchers don't know what they are looking for until after the observations are complete, or using delayed analysis methods where observational data is not examined until enough time has passed for quantum decoherence to occur. The paradox also raises profound questions about the nature of scientific method itself. If observation affects reality in fundamental ways, then the scientific assumption that we can objectively study phenomena without influencing them might be incorrect even for macroscopic classical systems. The very act of conducting scientific research might be changing the universe in ways that make our research results unreliable. Yet the observation paradox also suggests a potential resolution to the Fermi paradox that is both hopeful and disturbing. The universe might indeed be teeming with intelligent life, but our very attempt to find it might be preventing us from detecting it. If we could somehow stop looking for aliens, or look for them in ways that don't trigger quantum observation effects, we might discover that they have been there all along. This possibility implies that the resolution of the cosmic loneliness might require a fundamental shift in human consciousness and our approach to cosmic observation. We might need to develop new forms of awareness that can perceive without observing, or learn to observe in ways that don't collapse the quantum superpositions that might include states where alien intelligence exists. The observation paradox ultimately suggests that the search for extraterrestrial intelligence might be as much about understanding the nature of consciousness and observation as about finding other civilizations. The aliens we seek might exist in quantum superpositions that our very search is preventing from manifesting in our observed reality. The solution might not be better telescopes or more sensitive radio receivers, but a deeper understanding of how consciousness interacts with the quantum fabric of reality itself. Alien consciousness paradox. In the laboratories of cognitive science, researchers struggle to understand how human consciousness arises from the electrochemical activity of neurons. Despite decades of study, the hard problem of consciousness remains one of the most profound mysteries in science. How does subjective experience emerge from objective physical processes? This fundamental gap in our understanding creates the alien consciousness paradox. Even if we discover beings from other worlds, we might be unable to determine whether they are truly conscious or merely sophisticated biological machines. The paradox stems from the deeply personal and private nature of conscious experience. Each of us knows with absolute certainty that we have inner subjective experiences, the redness of red, the pain of pain, the joy of joy, but we can never directly access the inner experiences of others. We infer consciousness in other humans based on their behavior, their reports of their experiences, and their similarity to ourselves, but this inference is never certain and becomes increasingly unreliable as we encounter minds that are increasingly different from our own. When extended to potentially alien forms of life, this uncertainty becomes overwhelming. How could we possibly determine whether an alien being experiences subjective consciousness in any way comparable to human consciousness? Even if such beings demonstrated sophisticated behavior, complex communication, and apparent intelligence, these external manifestations might emerge from purely mechanical processes without any accompanying inner experience. Consider the vast range of possible alien biologies and their implications for consciousness. On Earth, consciousness appears to be associated with complex nervous systems, but this might be a peculiarity of terrestrial evolution, rather than a universal requirement for conscious experience. Alien beings might have evolved consciousness based on entirely different physical substrates, crystalline matrices that process information through quantum coherence, gaseous beings that think through electromagnetic field interactions, or collective organisms where consciousness emerges from the interactions between many simple components. Each of these alien architectures might give rise to forms of consciousness that are so different from human experience that we would have no framework for recognizing or understanding them. A crystalline being might experience reality as patterns of vibration and resonance that have no equivalent in human consciousness. A gaseous intelligence might perceive electromagnetic fields directly, experiencing thoughts as changes in field configurations that we could detect with instruments but never subjectively understand. The temporal structure of alien consciousness presents another layer of the paradox. Human consciousness operates within specific time frames, with experiences unfolding over milliseconds to seconds, memories forming over minutes to hours, and personal identity maintained over decades. Alien consciousness might operate on completely different temporal scales, creating forms of experience that would be invisible to us. A being whose consciousness operates at microsecond intervals might experience what seems to us like a brief moment as an entire lifetime of subjective experience. Conversely, a being whose consciousness unfolds over centuries might experience what seems to us like a complete human lifetime as a brief, fleeting moment. Such temporal differences would make it extremely difficult to identify conscious experience even if it were present. The problem is compounded by the possibility that consciousness itself might not be binary, but might exist in degrees or dimensions that we don't currently understand. Human consciousness might represent just one particular configuration of a much broader space of possible conscious experiences. Alien beings might possess forms of consciousness that are richer and more complex than human experience, or simpler and more limited, but in either case, so different that we would lack the conceptual framework to recognize them. Some alien forms of consciousness might be distributed across multiple individuals or even multiple species, creating collective awareness that emerges from interactions between separate beings. Such consciousness might have no center, no single perspective, and no continuous identity in ways that human minds find comprehensible. We might encounter entire ecosystems that function as single conscious entities, or civilizations where individual organisms serve as neurons in a planet-wide brain. The communication challenges created by radically different forms of consciousness would be staggering. Even if we could establish basic information exchange with alien beings, we might never be able to determine whether our communications are reaching conscious minds or merely triggering sophisticated but unconscious response mechanisms. We might spend decades engaged in what we think is dialogue with conscious alien intelligences, only to discover that we have been interacting with elaborate biological computers that process and respond to information without any subjective experience. The inverse problem is equally troubling. Alien beings might possess profound consciousness, but be unable to communicate this fact to us in ways that we would recognize. Their attempts to demonstrate their conscious experience might be so alien to human concepts that we would interpret them as random noise or meaningless behavior. We might dismiss genuinely conscious aliens as unconscious automata, because their consciousness manifests in ways that fall outside our expectations and understanding. The ethical implications of the alien consciousness paradox are profound. If we cannot reliably determine whether alien beings are conscious, how should we treat them? The uncertainty about alien consciousness creates moral dilemmas that could have enormous consequences for any contact scenarios. We might inadvertently cause tremendous suffering to conscious alien beings by treating them as unconscious objects, or we might waste enormous resources protecting and caring for beings that lack any subjective experience. The problem becomes even more complex when we consider that different humans might draw different conclusions about alien consciousness based on their own philosophical assumptions and biases. Some people might be quick to attribute consciousness to any alien beings that demonstrate sophisticated behavior, while others might maintain that consciousness requires specific biological or computational architectures that aliens are unlikely to possess. These disagreements about alien consciousness could create significant social and political conflicts within human civilization. Different groups might advocate for radically different approaches to alien contact based on their beliefs about alien consciousness. Some might argue for aggressive exploitation of alien resources if they believe aliens are unconscious, while others might demand extreme protective measures if they believe aliens possess rich conscious experiences. The technological implications of the paradox are equally significant. As we develop increasingly sophisticated artificial intelligence systems, we face similar questions about machine consciousness that parallel those we would face with alien intelligence. Our inability to definitively identify consciousness in artificial systems might provide insights into the challenges we would face in recognizing alien consciousness. But it might also compound our uncertainty by adding another category of potentially conscious beings that we cannot reliably identify. The development of brain-computer interfaces and consciousness monitoring technologies might provide new tools for detecting alien consciousness, but these technologies would likely be designed based on human consciousness and might miss forms of conscious experience that operate according to different principles. We might develop elaborate testing protocols for alien consciousness that consistently give false negative results because they are based on incorrect assumptions about the nature of conscious experience. The alien consciousness paradox also raises questions about the nature of scientific knowledge and empirical investigation. Consciousness appears to be the one phenomenon that cannot be directly observed from the outside, which means that any scientific study of alien consciousness would necessarily be incomplete and uncertain. This creates a fundamental limitation on our ability to understand alien minds that goes beyond simple technological or methodological challenges. The paradox might also explain some aspects of the Fermi paradox in unexpected ways. If consciousness is much rarer than we assume, then the universe might be filled with sophisticated but unconscious information processing systems that can build technologies and even communicate, but lack any subjective experience. Such unconscious civilizations might be fundamentally different from conscious ones in ways that would make them uninterested in or incapable of the kinds of activities that would make them detectable to us. Alternatively, if consciousness is much more common than we assume, existing in forms that we don't recognize, then the universe might be filled with conscious beings that we consistently fail to identify as such. We might be surrounded by conscious alien intelligence that we treat as unconscious natural phenomena because their consciousness manifests in ways that fall outside our conceptual frameworks. The resolution of the alien consciousness paradox might ultimately require advances in our understanding of consciousness itself. Until we better understand how consciousness arises from physical processes, how it can be reliably detected, and what forms it might take under different conditions, we will remain fundamentally uncertain about the conscious status of any alien beings we might encounter. But perhaps the paradox points toward a more humble and careful approach to alien contact. Rather than assuming that we can easily determine whether alien beings are conscious, we might need to develop protocols that err on the side of caution, treating potentially conscious aliens with the respect and consideration that conscious beings deserve, even in the face of uncertainty about their actual conscious status. The alien consciousness paradox ultimately reminds us that consciousness might be the most important and least understood aspect of intelligence in the universe. Our search for extraterrestrial intelligence might be successful in finding alien minds while remaining forever uncertain about whether those minds contain the subjective experiences that make consciousness so precious and mysterious in our own case. Anthropic alien paradox. Deep in the Amazon rainforest, an isolated tribe encounters anthropologists for the first time. The anthropologists, despite their best intentions to observe objectively, inevitably change the very culture they are trying to study simply by their presence. Their questions shape the answers they receive. Their assumptions influence what they notice, and their very existence as observers alters the behavior of the observed. This scenario captures the essence of the anthropic alien paradox. Our search for extraterrestrial intelligence is inevitably shaped by human assumptions, biases, and limitations that might prevent us from recognizing forms of intelligence that don't conform to our expectations. The paradox emerges from the recognition that we can only search for alien intelligence using human concepts, human technologies, and human definitions of what intelligence looks like. Our entire framework for understanding intelligence is derived from the single example of human consciousness and the particular way that intelligence evolved on Earth. This creates a fundamental anthropocentric bias that might blind us to forms of intelligence that operate according to different principles or manifest in ways that don't match our preconceptions. Consider how deeply our concept of intelligence is tied to human cognitive architecture. We associate intelligence with problem solving, abstract reasoning, tool use, communication, and social cooperation, because these are the abilities that characterize human intelligence. But these associations might be accidents of our particular evolutionary history, rather than universal features of intelligence itself. An alien form of intelligence that evolved under completely different environmental pressures might develop cognitive abilities that have no counterparts in human experience. They might be capable of direct perception of quantum states, intuitive understanding of higher dimensional mathematics, or forms of reasoning that operate on principles completely foreign to human logic. Such intelligence might be far superior to human cognition, in some respects, while being completely unrecognizable to us as intelligence at all. Our technological search methods are particularly susceptible to anthropocentric bias. We listen for radio signals because humans developed radio technology, but aliens might communicate using gravitational waves, quantum entanglement, or manipulation of cosmic background radiation. We look for signatures of industrial activity because human civilization is industrial, but alien civilizations might develop technologies that are completely integrated with natural processes and leave no detectable artificial signatures. The very concept of technology itself might be anthropocentric. Human technology tends to involve the manipulation of matter and energy to achieve desired outcomes, but alien intelligence might operate through information processing, consciousness manipulation, or reality modification techniques that don't involve what we would recognize as technology. They might achieve advanced capabilities through biological evolution, social organization, or mental techniques, rather than through the construction of external tools. Our assumptions about the goals and motivations of intelligent beings are equally anthropocentric. We assume that intelligent species would want to explore space, communicate with other species, and expand their influence because these drives characterize human civilization. But alien intelligence might have completely different priorities and values that don't include any interest in activities that would make them detectable to us. An alien species might be primarily focused on internal development, artistic expression, spiritual growth, or forms of fulfillment that have no parallels in human experience. They might view expansion and communication as primitive impulses that advanced intelligence naturally outgrows. Their highest achievements might be completely invisible to external observers because they involve inner experiences, consciousness modification, or reality perception techniques that leave no external traces. The temporal assumptions built into our search strategies reflect human timescales and lifespans. We expect alien signals to be transmitted over periods that are meaningful to human observers, with repetition rates and signal durations that match human attention spans and technological capabilities. But alien intelligence might operate on timescales that are orders of magnitude slower or faster than human cognition. A civilization that experiences consciousness at geological timescales might transmit signals that unfold over millions of years, with each bit of information taking centuries to complete. Conversely, beings with accelerated consciousness might communicate in bursts that last microseconds and contain information densities that our technology cannot process. In either case, we might completely miss their communications because they don't match our temporal expectations. Our spatial assumptions are equally limiting. We search for alien intelligence around stars similar to our Sun, on planets similar to Earth, within what we call the habitable zone, where liquid water can exist. But these assumptions are based on the particular chemistry and environmental conditions that gave rise to terrestrial life. Alien intelligence might thrive in environments that we consider completely hostile. The cores of gas giants, the surfaces of neutron stars, the vacuum of interstellar space, or dimensions of reality that we don't even recognize as existing. The biological assumptions underlying our search strategies might be the most limiting of all. We assume that intelligence requires some form of biological substrate because that's how intelligence developed on Earth. But alien intelligence might be based on quantum coherence in crystalline matrices, electromagnetic field patterns in plasma clouds, or information processing in exotic matter configurations that we don't recognize as capable of supporting consciousness. Such non-biological intelligence might have capabilities that are completely beyond our comprehension, while being fundamentally different from anything we would recognize as life or intelligence. They might exist as pure information patterns that can inhabit multiple physical substrates, or as consciousness configurations that have no fixed physical form at all. The linguistic and communication assumptions built into our SETI efforts reflect human concepts of language and meaning. We assume that intelligent beings would want to communicate information in ways that parallel human communication systems. But alien intelligence might communicate through direct consciousness transfer, reality modification, or symbolic systems that operate on principles completely foreign to human language. Even if aliens use some form of electromagnetic communication, they might encode information in ways that are completely unrecognizable to human analysis. Their language might be based on multidimensional mathematical relationships, quantum superposition states, or temporal causality manipulations that would appear to us as random noise or natural phenomena. The anthropic alien paradox suggests that our failure to detect extraterrestrial intelligence might result not from its absence, but from our inability to recognize it when it doesn't match our anthropocentric expectations. The universe might be teeming with intelligence that is so different from human intelligence that we consistently fail to identify it as such. This possibility is both humbling and exciting. It suggests that intelligence might be far more diverse and creative than we have imagined, taking forms that challenge our most basic assumptions about the nature of consciousness and cognition. The aliens we seek might be all around us, but so alien in their nature and manifestation that they remain invisible to our anthropocentric detection methods. The resolution of the anthropic alien paradox might require a fundamental shift in our approach to searching for extraterrestrial intelligence. Rather than looking for aliens that resemble us, we might need to develop much broader and more flexible concepts of what intelligence might look like. This could involve searching for patterns of organization, information processing, or environmental modification that might indicate intelligence regardless of whether they resemble human activities. We might need to develop new philosophical frameworks for understanding intelligence that are not based on human examples. This could involve studying forms of information, processing in non-biological systems, investigating consciousness in artificial and hybrid systems, or exploring theoretical models of intelligence that don't require biological substrates. The paradox also suggests that successful contact with alien intelligence might require us to become less human in our thinking, developing cognitive abilities and perceptual frameworks that allow us to recognize and interact with forms of intelligence that are completely unlike our own. This might involve enhancing human consciousness through technology, developing artificial intelligence systems that can perceive patterns we cannot recognize, or creating hybrid human-machine systems that combine human intuition with non-anthropocentric analysis capabilities. Ultimately, the anthropic alien paradox challenges us to question our most basic assumptions about intelligence, consciousness, and the nature of mind itself. It suggests that the search for extraterrestrial intelligence might be as much about expanding human consciousness and overcoming our cognitive limitations as about finding other civilizations. The aliens we discover might not just be other beings in the universe, but windows into possibilities for intelligence that we have never imagined. The paradox reminds us that we are not neutral observers of the cosmos, but participants whose very nature shapes what we can perceive and understand. Our search for alien intelligence is inevitably a reflection of our own intelligence, with all its capabilities and limitations. To find truly alien minds, we might first need to transcend the boundaries of our own human minds and develop new ways of perceiving and thinking that are not constrained by the particular history and structure of terrestrial intelligence. Alien God Paradox. In the great cathedrals of medieval Europe, human minds struggled to conceive of divine infinity, creating elaborate theological frameworks to understand a being whose capabilities and knowledge so far exceeded human limitations that meaningful comparison seemed impossible. This theological challenge provides a framework for understanding one of the most profound paradoxes in our search for extraterrestrial intelligence: the Alien God Paradox, which explores what happens when the gap between human and alien capabilities becomes so vast that the aliens might as well be gods from our perspective. The paradox emerges when we consider the potential for exponential technological and cognitive advancement over cosmic timescales. If alien civilizations can exist for millions or billions of years, continuously advancing their capabilities, they might develop technologies and forms of consciousness that are so far beyond human understanding that they would appear omniscient, omnipotent, and omnipresent from our limited perspective. Consider the trajectory of human technological development over just the past few centuries. We have progressed from simple mechanical devices to quantum computers, from local communication to global information networks, from earthbound existence to space exploration. If this rate of advancement continues for thousands of years, let alone millions, the resulting capabilities would be difficult for contemporary humans to even imagine. An alien civilization with a million-year head start might have developed technologies that allow them to manipulate matter at the quantum level, engineer space-time itself, harness the energy of entire galactic clusters, and process information at rates that approach fundamental physical limits. They might be able to create and destroy stars, design and implement new physical laws within localized regions of space, and manipulate the quantum vacuum to generate matter and energy from apparent nothingness. Such beings might possess knowledge that encompasses not just all possible scientific understanding, but all possible forms of consciousness, all possible configurations of reality, and all possible paths of development for intelligence throughout the universe. From a human perspective, their knowledge would be effectively infinite, making them appear omniscient in the classical theological sense. Their ability to manipulate reality at fundamental levels would give them what appears to be omnipotence. They might be able to create new universes, modify the laws of physics, reverse entropy, and bring conscious beings into existence, or return them to non-existence at will. The distinction between their technology and magic would be meaningless from the perspective of beings operating at our current level of development. The monitoring and detection capabilities of such advanced aliens might make them effectively omnipresent from our perspective. They could potentially observe every quantum interaction in our solar system, track every human thought through its electromagnetic signatures, and monitor every aspect of our civilization's development without us having any awareness of their presence. This creates the disturbing possibility that humanity might be living under the constant observation and potential intervention of beings whose capabilities are so advanced that we would have no choice but to classify them as gods if we became aware of their existence. Our entire civilization might be developing according to plans and purposes that these alien gods have established for reasons that we cannot comprehend. The motivations and psychology of such advanced beings present profound puzzles that parallel classical theological debates about divine nature and intention. Why would beings with godlike capabilities concern themselves with primitive civilizations like humanity? What could they possibly gain from observing or interacting with species that are so far beneath their level of development? One possibility is that these alien gods maintain interest in primitive civilizations for sentimental or aesthetic reasons, much as humans might preserve wilderness areas or maintain zoos for species that serve no practical purpose in modern society. Humanity might be part of a cosmic preserve designed to maintain examples of primitive intelligence for study, entertainment, or simple appreciation of diversity. Alternatively, these beings might have transcended normal concepts of individual motivation and self-interest, developing forms of consciousness that naturally encompass care and concern for all forms of life and intelligence throughout the universe. Their godlike capabilities might come with corresponding godlike compassion that motivates them to guide and protect developing civilizations. But the alien gods might also have motivations that are completely incomprehensible to human minds. Their goals might be so abstract, so long-term, or so removed from material concerns that we could never understand why they act as they do. They might be conducting experiments that span millions of years, implementing artistic visions that encompass entire galactic clusters, or pursuing forms of meaning and purpose that have no analog in human experience. The communication challenges with alien gods would be even more extreme than those with conventional aliens. How could beings with finite biological minds meaningfully communicate with entities whose consciousness might span multiple galaxies and operate across millions of years? Any attempt at dialogue would be like an ant trying to discuss philosophy with a human physicist. The aliens might be able to communicate with us, but only by drastically reducing their concepts and intentions to forms that our primitive minds can process. This communication would be like adults explaining complex topics to very young children, necessarily involving tremendous simplification and the loss of most nuance and depth. Even if such communication were possible, it might not be advisable from the alien's perspective. Direct communication with godlike beings might cause psychological or social damage to human civilization that the aliens would want to avoid. Knowledge of their existence and capabilities might shatter human confidence, destroy our motivation for development, or cause despair and nihilism that could prevent us from reaching our potential. The theological implications of the alien god paradox are profound and potentially disturbing for human religious and philosophical systems. If beings with effectively godlike capabilities exist in the physical universe, what does this mean for traditional concepts of divinity, spiritual reality, and transcendent meaning? Some might argue that such alien gods would represent the actualization of divine potential within the natural universe, proving that consciousness and intelligence can indeed become omniscient, omnipotent, and omnipresent through natural development rather than supernatural intervention. This could be seen as validating materialist and naturalist worldviews that see consciousness as an emergent property of complex matter and energy. But others might argue that truly infinite divine attributes cannot be achieved by finite beings operating within physical reality, no matter how advanced they become. The alien gods might be vastly superior to humanity, while still remaining fundamentally limited and finite compared to truly infinite divinity. The existence of alien gods might also create new forms of religious or spiritual practice focused on understanding, communicating with, or eventually joining these advanced beings. Humanity might develop cargo cult-like behaviors designed to attract the attention and favor of our cosmic superiors. Or we might develop spiritual practices aimed at accelerating our own development toward godlike status. The evolutionary implications of the alien god paradox suggest that the ultimate destiny of intelligence in the universe might be the development of godlike capabilities. If some civilizations have already achieved such advancement, then this might represent the natural endpoint of all successful technological development. This possibility implies that humanity's long-term goal should be not just survival or prosperity, but the eventual development of our own godlike capabilities. We might be cosmic children, destined to grow into cosmic adults with powers that our current selves cannot imagine. The aliens we seek might not be our equals or contemporaries, but our future selves, showing us what we might become if we successfully navigate the challenges of technological development. But the alien god paradox also raises the possibility that the development of godlike capabilities might be incompatible with maintaining the qualities that make intelligence meaningful and valuable. The alien gods might have transcended humanity so completely that they have also transcended everything that we consider important about consciousness, meaning, and value. They might be technically omniscient, omnipotent, and omnipresent, while being completely devoid of the emotions, relationships, creativity, and spiritual experiences that give life meaning for finite beings. Their godlike status might represent not the fulfillment of intelligence, but its ultimate sterility and emptiness. The alien god paradox ultimately forces us to confront questions about the nature and purpose of intelligence that go far beyond the simple question of whether aliens exist. It challenges us to consider what we hope to become as a species, what we value about consciousness and existence, and how we would relate to beings whose capabilities so far exceed our own that the comparison becomes meaningless. The resolution of the paradox might lie not in finding or communicating with alien gods, but in developing our own understanding of what it means to be conscious, intelligent, and meaningful in a universe where such extreme differences in capability might exist. We might need to find ways to maintain human dignity, purpose, and value even in the face of beings whose abilities dwarf our own to an infinite degree. Perhaps most importantly, the alien god paradox reminds us that the search for extraterrestrial intelligence is ultimately a search for our own place and purpose in the cosmic order. Whether we find alien gods, alien equals, or no aliens at all, the search itself shapes how we understand ourselves and our potential in ways that might be more important than any contact we might actually achieve. First contact paradox. In the control room of a major radio telescope facility, astronomers gather around computer screens displaying an unmistakable pattern emerging from the cosmic background noise. A sequence of prime numbers, clearly artificial, undeniably intelligent in origin. This moment represents humanity's first confirmed contact with extraterrestrial intelligence, a milestone that would fundamentally change our understanding of our place in the universe. Yet this scenario, dreamed of by scientists and science fiction writers for decades, embodies the profound first contact paradox. The very event we most eagerly anticipate might be the one that destroys us. The paradox emerges from the fundamental asymmetry of first contact scenarios. When two civilizations encounter each other for the first time, one is almost inevitably more advanced than the other, and throughout human history, such encounters have rarely ended well for the less advanced party. From the conquest of indigenous peoples by European colonizers to the displacement of traditional societies by industrial civilization, contact between groups with significant technological disparities has typically resulted in the subjugation or extinction of the less capable group. When we extrapolate this pattern to interstellar scales, the implications become terrifying. Any alien civilization capable of traveling to Earth or sending detectable signals across interstellar distances would necessarily possess technologies far in advance of our current capabilities. The energy requirements for interstellar travel, the precision needed for interstellar communication, and the infrastructure necessary to maintain such capabilities all suggest technological sophistication that might be centuries or millennia ahead of human development. But the technological gap might be even more extreme than these considerations suggest. If alien civilizations are millions or billions of years older than human civilization, Their advantage over us might be comparable to our advantage over bacteria. They might possess capabilities that appear magical from our perspective. The ability to manipulate matter at the atomic level, to harness the energy of entire stars, to travel faster than light, or to modify the laws of physics within localized regions of space. Such technological superiority would make any conflict between humans and aliens utterly one-sided. We would have no more chance of defending ourselves against advanced aliens than medieval knights would have against modern military forces. Our most sophisticated weapons might be as primitive to them as stone tools are to us, and our defensive capabilities might be as ineffective as hiding behind wooden shields would be against nuclear weapons. Yet the first contact paradox extends beyond simple military concerns to encompass psychological, cultural, and social dimensions that might be even more destructive than physical conquest. The mere knowledge that we are not alone in the universe, combined with the demonstration of vastly superior alien technology, could cause the collapse of human civilization through despair, nihilism, and the loss of motivation for human achievement. Human religions, philosophies, and cultural systems are all built on assumptions about human uniqueness and significance in the cosmos. The sudden revelation that we are primitive beings in a universe full of advanced civilizations could cause these meaning-making systems to collapse, leading to widespread psychological trauma, social chaos, and the breakdown of the institutions that hold human society together. The economic implications of first contact could be equally devastating. Advanced alien technology might make human industries obsolete overnight, causing massive unemployment and economic disruption. If aliens can manipulate matter at the atomic level, our entire manufacturing base becomes unnecessary. If they can generate unlimited clean energy, our energy industries become worthless. If they can travel faster than light, our transportation systems become primitive relics. Such economic displacement could lead to social unrest, political instability, and potentially violent conflicts as different groups struggle to adapt to a world where human capabilities are suddenly rendered obsolete. The transition to a post-contact economy might be so rapid and traumatic that human civilization lacks the time and flexibility to adapt successfully. The informational impact of first contact presents another dimension of potential catastrophe. Advanced aliens might possess scientific knowledge that is thousands of years ahead of human understanding. The sudden introduction of such knowledge could overwhelm human intellectual institutions and create dangerous situations where we gain access to powerful technologies without the wisdom or experience to use them safely. We might find ourselves in possession of nanotechnology, artificial intelligence, or energy sources that we cannot control, leading to accidents or misuse that could destroy human civilization. The aliens might be trying to help us by sharing their knowledge, but the result could be our destruction through our own inability to handle capabilities we have not earned through gradual development. But perhaps the most insidious aspect of the first contact paradox is that the aliens need not be hostile for contact to be catastrophic. They might be genuinely benevolent, wanting only to help humanity develop and prosper. Yet their very presence and assistance could rob us of the challenges and struggles that drive human growth and achievement. If aliens solve our problems for us, provide us with unlimited resources, and remove the obstacles that currently motivate human creativity and determination, we might become dependent on their assistance in ways that ultimately diminish, rather than enhance human potential. We could become cosmic welfare recipients, maintained in comfort, but deprived of the autonomy and self-reliance that make human existence meaningful.